The Honorable, the Dean of Faculty of Engineering, Universitas 11 Maret, Dr. I.R. Solihin As'ad, MT. Distinguished speakers, General Chair of International Conference on Industrial, Mechanical, Electrical, and Chemical Engineering, Mr. Mujtahid Kaifisina, PhD, and our respectable presenters and participants of this conference.
Assalamualaikum warahmatullahi wabarakatuh. Good morning. We are delighted to welcome you to the opening ceremony of the 7th International Conference on Industrial, Mechanical, Electrical, and Chemical Engineering 2021, organized by Faculty of Engineering, Universitas 11 Maret, Surakarta, Indonesia.
It is our pleasure to be your master of ceremony for this session. I am Ramanda Ayudamayanti.
And I am Samira Kailabianti.
We would like to extend a very warm welcome to all of you. We appreciate you taking time of your busy schedule to join us today.
Ladies and gentlemen, this conference is aimed to provide opportunities for delegates to exchange new ideas face-to-face, to bring together leading academic scientists, researchers, and research scholars to exchange and share their experiences and research results on all aspects of engineering, science, and technology. Therefore, these conferences will feature presentations by international speakers which are cutting-edge session topics. Dear ladies and gentlemen, for a brief moment, we would like to start our agenda with the song of Indonesia National Anthem, Indonesia Raya.
Excellencies, participants, ladies and gentlemen, we are now going to listen to the opening speech delivered by the Dean of Faculty of Engineering, and afterward, we would like to request the Dean of Faculty Engineering Universitas 11 Maret to officially open the 7th International Conference on Industrial, Mechanical, Electrical, and Chemical Engineering 2021. Ladies and gentlemen, please welcome Dr. I.R. Solihin Asad, MT.
Okay, thank you, Ms. Amanda and Samira. Uh, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. It's a very good morning and good evening wherever you are. The honorable keynote speakers, professors, invited speaker, participants, the committee, and colleagues, ladies and gentlemen. My name is Solihin Asad. I'm currently a Dean of Faculty of Engineering, Universitas 11 Maret or UNS Indonesia. On behalf of the Faculty of Engineering, Universitas 11 Maret, I would like to extend my warm welcome to all of you in this 7th International Conference on Industrial, Mechanical, Electrical, and Chemical Engineering, or the 7th Icimece 2021. Thank you for joining. Ladies and gentlemen, due to the global pandemic of COVID-19, we have to conduct this conference through virtual modes. However, this will not degrade our objective for making this 7th Icimece 2021 as a forum to share and to discuss the ideas and research on engineering, science, and technology. This conference was formerly known as Icimece, which was held in November 2015, 6 years ago, and it transformed to Icimece a year later. It is actually the annual conference, which was usually held in Surakarta, Indonesia. Ladies and gentlemen, the theme of the 7th Icimece is sustainable technology innovation and commercialization for pandemic recovery. The reason of selecting this theme is Indonesia and the global world have been facing pandemic COVID-19 for more than a year with uncertain situation. This made a tremendous impact on quality of life, individual and community. It takes a lot of effort to restore to the previous normal situation. Ladies and gentlemen, a continuous innovation on technology and commercialization are needed in responding the needs of individual, societies, and industry toward the new normal phase. Ladies and gentlemen, the committee of Icimece have received accepted about 101 papers after reviewing from 116 papers from various countries, including Canada, China, Estonia, Germany, Japan, Malaysia, Saudi Arabia, South Korea, Thailand, United Kingdom, Vietnam, and Indonesia itself. All accepted paper will be published and will be presented virtually through Icimece 2021 website channel. And this paper will be published in Reportable Proceeding Series AEP Proceedings. Ladies and gentlemen, selected paper from these papers will be recommended to publish in reputable journal, such as Evergreen, Journal Technology, Asian Journal of Chemical Engineering, and Malaysia Journal of Fundamental and Applied Science. Ladies and gentlemen, as the high number of papers presented, I hope this triggers a collaboration among the researchers who participated in this event. International engagement and cooperation are very important in solving the global problem that we are facing now. This is in line with our conference, which we are conducting now. Ladies and gentlemen, last but not least, I especially thank the all keynote speaker, Professor Muhammad Godan Kibrani from University of Calgary, Professor Koji Inoki from Japan, Professor Shatar Isfrakrar from Malaysia, from UTA Malaysia, and Professor Somyot Kait Walid Kilai from KMI TL Thailand, and Professor Hendro Jacksono from Jakob University of Bremen, Germany. And also, I would like to thank to all invited speakers, the participant, the sponsor, the committee, and the partner for their contribution, and all the committee for their great effort to organize this conference. With Bismillahirrahmanirrahim, I declare the 7th Icimece of 2021 is especially open. I wish you a successful and enlightenment conference. We are looking forward to working with you all. Have a great day. Assalamualaikum warahmatullahi wabarakatuh. Thank you very much. Back to you, Amanda and Samira.
Thank you, Dr. IR Solihin Asad MT, for the opening speech. Ladies and gentlemen, before we move to the next agenda, we would like to invite you to open the camera and take a position for a photo session. Please open the camera. Well, thank you for your kind cooperation to open the camera.
We are now continuing our meeting to the next agenda, that is to hear the keynote speaker session, which will be moderated by Dr. Sunu Herwi Pranolo. Before we hand out the session, please allow me to give you a brief introduction of our moderator background. Dr. Sunu Herwi Pranolo was born in Indonesia, 1969. He was received his doctoral degree from Bandung Institute of Technology. During 2018 to 2020, he has been conducting research on palm kernel shell gasification for supplying heat in asphalt mixing plant. Since 1998, he has been an associate professor in Chemical Engineering Study Program at Universitas 11 Maret, Surakarta, Indonesia. Ladies and gentlemen, please welcome Dr. Sunu Herwi Pranolo.
Check monitor. Is clear? Miss Bianti. My sound is clear? Hello?
Yeah, it's clear, Pak Sunu.
Thank you very much, Dian. Well, thank you, Miss Bianti and Miss Damayanti, for concise and comprehensive introduction. Good morning, good afternoon, and good evening, ladies and gentlemen. The Honorable Dean of Engineering Faculty, Universitas 11 Maret, the Honorable Chairman of Icimece 2021, and the distinguished speakers from all over the world. Ladies and gentlemen, please allow me to deliver you my warmest greeting from Universitas 11 Maret of Surakarta, Indonesia. On this annual conference occasion, I'm Sunu Pranolo, taking the role as your moderator for our first and second keynote speakers this morning. Let's welcome Professor Dr. M. Kulam Kibria of University of Calgary, Canada, and Dr. Koji Enoki of University of Electrocommunication in Tokyo, Japan. I'm pleased to greet our distinguished speakers here. Good evening, Professor Kibria. How are you?
I'm doing great. How are you?
Well, thank you very much for your participation here. What time is it now in your country?
7 p.m.
At 7 p.m.
Yeah.
You are 13 hours behind us here in Solo.
Yeah.
So far away, yeah? And the other side of the world.
I'm sorry?
In the other side of the world.
Yeah, exactly.
Okay, thank you very much. And second keynote speaker, do I have Dr. Koji Enoki here? I would like to send my greet. Not yet? Okay, no problem. Maybe she's on the way to this session. Well, it is very pleased to have Professor Kibria here in this conference, and we really appreciate your willingness to be here with us, although you are far away from Universitas 11 Maret, 13 hours behind us. Well, audience, in the first session, I'd like to invite Dr. Gulam Kibria for presenting his topic of materials and systems for the synthesis of renewable feedstocks and fuels. We believe that renewable feedstocks and fuels are promising now, and Professor Kibria is one of outstanding researchers in this area. Anyway, before presentation, I'm glad to convey you Professor Kibria's brief profile. Professor Kibria is interested in heterogeneous catalysts and system design for energy transformation reactions. His current research interests include nanomaterial synthesis for next generation catalysts, carbon dioxide reduction, water oxidation reaction, device engineering, and techno-economic analysis. Before joining University of Calgary as assistant professor in the Department of Chemical and Petroleum Engineering, he worked as postdoctoral fellowship in University of Toronto, Canada. Again, I'm glad to mention here several scientific achievements of Professor Kibria, such as academic gold medal Tomlinson doctoral fellowship from McGill University, and what else? Green Talents Award from German Federal Ministry of Education and Research. Ladies and gentlemen, please welcome Professor M. Gulam Kibria. And Professor, the next 30 minutes is yours.
Thank you, Professor Sunu, and thanks for the kind invitation. And it's really an honor to be here. Although I wanted to be in person to see the beautiful country, but unfortunately, maybe next time I'll be able to visit. All right. So good morning, everyone. And for the people joining from other parts, good evening or good afternoon. So let me share my screen and I'll start from there. Can you see my screen?
Yes. Yeah, it's clear.
It works now.
Professor Kibria, it's clear.
All right. So yeah, sometimes I go over my time limit. So if I'm crossing 30 minutes, just let me know so I can finish on time. All right. So as Professor Sunu mentioned, I am Mohammad Gulam Kibria, Assistant Professor in Chemical and Petroleum Engineering here at the University of Calgary. And I know the audience is pretty broad, so I tried to keep it a little bit general. So I'll not go to fundamentals of thermodynamics or kinetics, but I'll try to keep it general so it's suitable for and would be probably interesting for everyone to listen. All right. So before I start talking about sustainability and renewable fuels and feedstock, maybe I can give you a little bit of background of where we are currently. Canada is pretty broad, pretty big. So let me just give you where we are located. So this is Canada, and as you can see on the western part, this is Calgary, and this is the province of Alberta, and we are close to the British Columbia. So that's the Pacific Ocean side. So Calgary is one of the probably 4 largest and most brightest city in Canada. We have we get lots of sunshine throughout the year, but we also get lots of cold weather as well. So this is city of Calgary. So it's a city of Calgary was the host of 1988 Olympic that time. So so it's a beautiful city. It's nice weather there as well, but in winter it becomes also very cold. This is the University of Calgary. It's pretty big. We have around 45,000 students, including undergraduate and graduate students. And this is the building we are located. This is University Research Center. And you see the other side. So these are all the university area. Part of these buildings are also part of University of Calgary. So we are not far from Canadian Rockies. It's probably 1-hour drive, and we see the beautiful mountains and the nice lakes there. So it's pretty nice in summer. If you drive there, it's pretty beautiful out there. All right, so that was kind of some of the background of where we are located, but let's talk about some science and engineering. So as I'm sure everyone knows about the global warming and where we are heading. So if you look into the historical emissions starting from 1980s, as you can see that our emission keep growing over time. On the y-axis, I show the emissions from fossil fuels from the most carbon-intensive industries, including cement industries. So this is a gigaton of CO2 per year. And as you can see that the way we are emitting carbon dioxide over the years, and if we keep this current emission rate, then we are on track to hit 3.5 degree to 3.6 degree by the end of the century. So that's why there are the different nations came across this Paris Agreement to discuss about what can we do. So according to Paris Agreement, we really want to keep the temperature below 2 degree or below 1.5 degree by the end of the century. So what we are looking at is drastically different route as compared to where we are heading with our current emission rate. So we really need drastic innovations in terms of carbon CO2 removal, CO2 capture, CO2 sequestration, and CO2 conversion as well. So that is the topic of my talk today. I want to talk about how we can utilize CO2 and make something valuable that we can use probably using CO2. So the good news is that the carbon capture technologies are emerging. And as you see in the news, you will see lots of innovations coming across these CO2 capture technologies from flue gas, from air. So this is one example of CO2 solution. This is in the eastern part of Canada. So they are capturing CO2 from flue gas. So that is their patented technology. On the right side, you see this is from Carbon Engineering. You might have heard of it. Their name, Carbon Engineering, they are one of the companies looking for innovations where they can capture CO2 from air. So there are technologies that can capture CO2 from flue gas and also from air. And the other thing is that in terms of opportunities is that the price of renewable electricity is dropping over the years. If you look into the photovoltaic cell module price, and today we are talking about 2 cents or even below 2 cents per kilowatt hour of electricity. So that gives an opportunity to utilize this cheap renewable electricity. But the problem of renewable electricity is that, as you know, it's intermittency. So we get, when the sun shines, we can produce electricity, but at night we need to find a way to store that. So we really need to find a way to store, distribute, and deliver renewable electricity on demand. So from one side, the good news, the price is dropping. Other side, we need to figure out a way to store renewable electricity and then transport renewable electricity, right? So what we can do and what we are doing right now is to use chemical bonds to store energy. One example could be you use solar energy and then you split water, you make hydrogen, and hydrogen you can use in chemical industries, you can use as a fuel, you can use for generating electricity back using fuel cells. So in other words, using sunlight, you can split water and generate hydrogen, which can be used as a medium of storing and transporting energy. Other options could be you can convert CO2 using electricity or from sunlight, and then make some chemicals, for example, methanol. This is a chemically uphill reaction, 1.2 volt. So that means once you overcome this energy barrier, you can store that amount of energy. And once you produce produce chemicals or methanols in this case, then you can use it for different chemical industries as well. So we see opportunity to store energy in chemical bonds, and then we can use that for many purposes. And that is a talk. That is a topic that I want to talk about. How we can convert CO2 and make some chemical fuels or chemical feedstocks that we can use. In terms of energy or storage, you might be thinking of why not batteries, why not flywheels, or why not supercapacitors. There are pumped hydro and thermo mechanical storage technologies out there, but you need to think about in terms of the energy density, right? So if we look into the rated power, which is shown on the x-axis, on the y-axis are showing the how long you can store it, right? For example, you need to store, let's say, for a couple of months. So in that sense, you see that chemicals or hydrogen or methane or hydrocarbons in general can store a lot more energy as compared to any other energy storage technologies out there. Just to put that into perspective, for example, a full tank of gasoline in your car is equivalent to electrical energy stored in 80,000 iPhone 6 batteries. So just imagine how enormous amount of energy you can store in chemical bonds. And that's why we are focusing on these chemical means of energy storage. So ideally, what we want to see is that we want to use this renewable and cheap electricity, whether it's photovoltaics, whether it is from wind power, or it's from hydroelectric. We want to use this low carbon and cheap electricity. And on the other side, as I mentioned, there are innovations on air CO2 capture from air or from flue gas. So if we can bring CO2 and then we bring our renewable electrons or renewable electricity, and then we want to electrochemically convert CO2 to make chemicals or fuels. So this chemical can be used as in the industries where you need low carbon chemicals, and that can significantly reduce the carbon intensity. On the other hand, if you want to use it as a fuel, you burn it, transport it, store it, or you burn it in your vehicle, and then it will go to the air. You can capture it if you have air capture technology is there. So that is the area we are looking at, how we can efficiently convert CO2 to make fuels and feedstocks. So if you look into the electrochemical system, so this is the interface between electrical and chemical engineering aspects. So what we have here is that we have two electrodes. On one side, we are oxidizing water to make oxygen. On the other side, we are reducing CO2 to make fuels. So we are oxidizing water to make oxygen. On the other side, we are reducing CO2 to make a product. So what kind of products we are talking about? We are talking about a spectrum of products that can be produced from CO2. For example, you can think about carbon-1 products, carbon monoxide, formic acid, methanol has a huge market. Methane, these are the renewable methanes we are talking about. You can make C2 products, for example, ethanol can be used as also ethylene has a huge market for polyethylene industry and so on. So these are some of the possible products that people have already demonstrated the feasibility of making these products from CO2. So then what is the challenge, right? So you might be wondering, what is the challenge that we are working on? So there are two challenges. One, of course, is from a thermodynamic aspect. So these are the half-cell electrochemical reactions that from CO2 to make CO, formic acid, methanol, methane, ethylene, and so on, right? However, if you look into their thermodynamic potential on this right side, you see that they are very similar from one to other. So in other words, if we really want to make one particular product, so you have to have a very selective catalyst that can make one particular product. Otherwise, if it is not selective, then you will end up producing, let's say, 10 different products, and then you have a separation problem, right? So how do you separate it? And what is the energy intensity of that separation process, and so on. So the development of a selective catalyst is one of the primary areas that people are working on, including ourselves. So the second challenge is from the kinetics. So when you look into the CO2 to make a product, for example, ethylene, you see that how many steps it's coming through. So from adsorption to dimerization to desorption and so on. And in this pathway, you will see there are some other products that we are making. So in other words, that again, going back to the production of single product instead of making a multiple products. So this becomes really challenging. So both from thermodynamic and from the kinetic aspect, developing a catalyst is very crucial that can selectively make a product and which can be from looking from a process energy perspective and from an economic perspective is very important to develop such selective catalysts, and that is something we are working on. So we do system level analysis, including techno-economic and also life cycle analysis, and this is one example of what we try to do. We look into the conventional process and what is their levelized cost or market price. For example, I'm showing the market price of ethanol, which is around $600 per ton. And the blue one is ethanol produced from CO2. With, of course, some assumptions that we will achieve 90% selectivity, energy conversion of 60%. If we can hit these target numbers, we can make ethanol, which is even cheaper than the current ethanol, which is produced from fossil fuel or chemicals with carbon intensive process. So we clearly see some products that might be quite interesting than others. For example, ethanol is a good target product that we should be looking at. Formic acid, although it's quite interesting, but the market size of formic acid is not that great. So we are really looking at that products or the CO2 derived product that has a huge market. So that's in that aspect, methanol, ethanol, ethylene is quite interesting. So when we look into from a other side, from a life cycle perspective or from a total overall carbon intensity of the process. So on the Y side, I'm showing a CO2 emission to make 1 kg of product. So kg CO2 per kg of product. And these are the different products that we can make from CO2. So if you look into the conventional process or the incumbent processes, we see that the carbon intensity as shown here. We are also looking at the thermochemical process to make, for example, ethylene from ethane cracking. And the other one, the blue one, this is the electrochemical process. So for ethylene, it looks quite interesting, but for some of the products, for example, to make methanol, we see that the energy is, the CO2 emission is quite high. And this comes, it comes down to the fact that we really need to improve the energy efficiency of the process. And this is one life cycle analysis that my student Nabil has worked on. So we try to look into from a bigger perspective to see what are the key target metrics that we want to achieve. And when we talk about the figures of merit for electrochemical CO2 reduction, we see there are a number of things that we have to improve. Number one is the current density. This is related to the throughput of the process, how fast you can make a product. And using a gas diffusion electrode, we can significantly improve the productivity of CO2 reduction. The second thing, or another aspect, that is the energy efficiency. How can we make that 60% energy efficiency for the process? And the other aspect, which is the stability, which we are also working on. So I'll focus my talk on these 3 aspects to improve the energy efficiency of electrochemical CO2 conversion. So I'll talk about 3 aspects. Number 1, or the approach 1, is the new anode chemistry, margin capture and conversion, and the third one is solid polymer electrolyte cell. So approach 1 is new anode chemistry. So why do we need anode chemistry? So if you look into a CO2 electrochemical process, as I mentioned, on one side we have water oxidation reaction, other side we have CO2 reduction reaction. Now, the problem of this design is that water oxidation reaction is energetically very expensive. So we need 1.23 volt from anodic oxidation reaction. And if you look into the overall energy spent in this case, you will see that nearly over 85% of the energy that goes for the side reaction. We are interested in CO2 reduction, but you see that 85% of the energy we are simply wasting for making oxygen. Of course, oxygen has a value, and in COVID situation, maybe this is quite important. But if you look into from an overall energy aspect, you see that the most of the energy goes for the anodic reaction. So what can we do? So we need to reduce the thermodynamic voltage, or we need to oxidize something, not water, so that you can significantly reduce the voltage, or in other words, reduce the energy for the overall process. So this is what one example. So this is water oxidation current as a function of voltage. And we are interested in some other, it could be alcohol oxidation, or it could be some bio waste, where you can oxidize that and reduce the energy for the overall process. And one example we are working on is bio waste from biodiesel industry, where we can oxidize glycerol, it can be crude glycerol, to make a number of valuable products, including glycolic acid and formic acid. So from one side, you are making valuable products, more valuable than oxygen. On the other side, we are reducing the overall cell voltage, and that way we can improve the energy efficiency of the process. So what we are essentially doing is, on the cathodic side, we are doing CO2 reduction to make a product. On the anodic side, instead of doing water oxidation, we are feeding glycerol, we are making some formic acid or glycolic acid. And by doing so, we are significantly reducing the overall cell voltage or saving the energy. And this is one example. My postdoctoral fellow, Adnan, he started his new job recently. So he was working on this catalyst development, where we developed gold nanodendrite catalyst on nickel foam. And we showed that we can reduce the voltage by almost 0.8 volt from a water oxidation reaction. So if you oxidize glycerol on gold nanodendrite, we can reduce almost 32% energy for CO2 electrochemical process. And we also showed that the current density can be significantly improved, significantly better than what has been reported in last decade. So that was a significant step forward to show that indeed we can scale up this process and produce high current density. While doing that, we are also maintaining the selectivity. As you see that we are maintaining selectivity as high as 50%. And at the same time, we are reducing the voltage almost by 0.7 or 0.8 volt. So typically you would produce 4.7 volt, where we are, by doing water glycerol oxidation reaction, we are able to do it at below 4 volt. So that significantly improves the energy efficiency of the process. And the other aspect for this using a bipolar system is the fact that when you look into electrochemical CO2 reduction, what happens is that instead of converting CO2 to make a product, because most of the people use alkaline system, so CO2 reacts with alkaline system and produces carbonate. So a lot of CO2 gets converted to carbonate, they transport it to the anode, and then released back to CO2. So essentially, you are not converting a significant portion of your CO2. So what we try to do here is that we use a bipolar membrane, which suppresses the crossover of carbonate to the anodic side. And we showed that the crossover can be minimized to as little as 0 within few hours, but within extended period of time, we still see some crossover, but we are working on this aspect as well. And if you look into from a cost perspective as well, if you make ethylene, for example, from CO2, then the levelized cost can be, let's say, $7 per kg of ethylene. However, if you replace water oxidation with glycerol oxidation, we can reduce down to below $2 per kg. So in other words, we are almost saving 70% of the cost for making ethylene from CO2. So the second aspect I want to talk about is margin capture and conversion. So when we talk about conversion, we need to think about what is going on from capturing all the way to the conversion plant. So if you think about the whole process, we see that when you capture CO2, then your conversion site may not be at the same place where you are doing the capture process. So in other words, once you capture it with some solvent materials, then you have to regenerate it. And this regeneration is sometimes really energy intensive. And if the capture and conversion plants are far apart, then in that case that you have to compress it, you have to store or transport it, and then bring it to a conversion site where you do the conversion. And in each of these processes, you will see that there is significantly energy and money involved. So we thought, can we make an integrated process where the capture and conversion will be happening at the same place? And with that in mind, we started to work on a material where you start with the flue gas. So flue gas coming in from one side. I'll talk briefly about what material is that, to capture CO2 and then convert CO2 using a silver catalyst. So again, a dilute stream of CO2 coming in, you are capturing, you are converting, and then this is the product that you can make. So in other words, we are doing in situ CO2 capture and conversion system, and we are quite excited with some of the recent results that we got from there. So this is the metal organic framework that we are working with one of my collaborators, which is a metal organic framework to capture CO2. And this metal organic framework is quite stable in water, and also we showed that even in steam cycling, this MOF is quite stable. So, and then together with my collaborators, we are working on that front. At the same time, we also thought, can we use some other solvents? For example, recently we started to work on using plastic waste and doing some pyrolysis process. We are making some CO2 sorbent simply from waste plastic. So these are the material we are using to capture CO2. If you look into the CO2 capture or uptake, this is our CO2 and this is our nitrogen. So you can see that there are probably some materials we can generate in very simple ways. And in this case, one example of just using some plastic waste to make these kind of solvent materials. This is a cross section of the device we are talking about. So this is our catalyst for conversion, and this is our gas diffusion electrode. And this side, we have the capture material to capture CO2. And as you can see that we're using copper for conversion, and the fluorine comes from the gas diffusion electrode. And also we see some carbon. So we clearly see that structure is working. We're trying to understand how this reaction is happening, because we are not doing any regeneration process. So it's capturing and doing some in situ regeneration process. We are still not sure what exactly the mechanism is, but this is areas where we are working on. And some of the results that we started with like 10% CO2 in this case. And as you can see that at 1.4 volt, this is the CO2 Faraday efficiency as high as 90%. When we do not have a capture material, this is the selectivity you get, almost 50%. However, when we add this capture material, we significantly boost the selectivity, because essentially you are concentrating the CO2 that is coming from flue gas and then letting the conversion happen. So you're concentrating CO2 and then the conversion is happening. Another good example is that this is the CO Faraday efficiency. And we show that by increasing the loading of your capture material, you can significantly improve the Faraday efficiency. And the last one is the solid polymer electrolyte cell. And as I mentioned, that in typical processes, people use alkaline electrolyte, and that significantly takes lots of CO2 and then passes to as a form of carbonate. So it's simply a waste of CO2 that you are capturing. So what can we do to avoid that? So we started looking at a solid polymer electrolyte instead of alkaline electrolyte. So this is our solid polymer electrolyte. So the CO2 is coming from this side, and then we do not have any electrolyte. So there is no carbonate formation or loss of CO2. Then there are some, of course, challenges of solid polymer electrolyte, and one of the big challenges is the acidification of the membrane. Because when you have a bipolar system, we find that the membrane becomes acidified, and then the CO2 reduction selectivity drops, and the side reaction, which is hydrogen production or hydrogen evaluation reaction, this starts to dominate your process. So my student Mufle, he's also from Indonesia. So he's working on solid polymer electrolyte. So this is the area we are working on. So we are developing a cation and anion exchange membranes or ionomers, which can suppress the crossover and also maintain the stability of the process. And some recent results are quite interesting. As you can see that from a commercial bipolar system, all you produce is basically hydrogen. but this is not our intentive, our purpose of producing hydrogen. We want to reduce CO2. And using a solid polymer electrolyte, we show that this is our ethylene production. So as you can see that where the ethylene is barely minimum, you cannot see it. Here we show that almost 40% selectivity for ethylene formation using our solid polymer electrolyte. So you might be wondering, okay, I understand all these things. So how scalable is this process? Is it really feasible for a commercial level? So I will give you some examples of how can we scale this up. This is the scaling part is quite straightforward because the scaling part is similar to a commercial water electrolysis process. So from a lab scale cell, you can make a pilot scale cell simply having a bigger electrode size, and then you can stack them. And then after that, you can do simply modular scaling to make as your scale you need for your process. And some example that we started with 1 centimeter square cell in our lab. And this is the, if you look into inside of a cell, there are multiple components for gas flow, for liquid flow, for current collection, and so on. But the active area is pretty small. So what we started to do is to make a bigger electrode. So this is a blade coating technique where we used, we developed 100 centimeter square cell, the active area of your electrode in this case. And initial trials were really difficult. And these are some of the failures. Some people do not like to show those failures, but I like to show some of the challenges that we really faced. And lots of trials, there are some mechanical failure. There are some, because we are dealing with an interface where from one side we are passing gas, on the other side we are passing liquid. So maintaining that gas and liquid interface is quite challenging. So we are working on that. But after a couple of trials and some design, so this is the real example of what we did. So this is our lab scale 1 centimeter square cell. You can see a small one, just probably you can hold it in your hand. And then we made a bigger one, 100 centimeter square electrode, and then we stacked them. So this is our 1 centimeter square cell, and this is our 1,000 centimeter square cell. So we scaled that system to 1,000 times, and this was one of the good examples of how can you scale these processes. And this is the cell in operation, because this is just a small part of your whole system, because you need flow pumps for the liquid, you need gas meters, and all these things need to be working together. And I was very fortunate to be part of a Carbon X Prize competition. It was a global competition, and my team was one of the 10 finalist teams around the world. So we were able to show that electrochemical process can be scaled up and we can convert CO2. And in this specific example, we converted to carbon monoxide, which can be used as in Fischer-Tropsch and other downstream processes for making some products. So other areas I will not probably have time today, but just one slide that we are working on the biomass conversion to make green hydrogen and value-added chemicals. So we are working on raw biomass and some pre-treated biomass, and using some photocatalyst that we are working in the lab. So this is some example of photocatalyst. We are working on zinc cadmium sulfide in collaboration with my colleagues to show that we can convert the cellulose and the lignin to make some using photocatalysis to make lactic acid and also green hydrogen from biomass. So there are probably 10 or 15 people working in the biomass conversion area, but this is probably a topic for another day. So this is my group. I was very fortunate to have group members from across the world, from Indonesia, from India, from Pakistan, from Iran, China, and also Brazil, probably 10 different countries. I have, so this is the nice family of Mufle. So they are from Indonesia. He joined me back in 2020, January. And so, yeah, has been quite impressive. So with that, I don't know if I passed my time, but I'd like to acknowledge all the financial support from the University of Calgary, from Schulich School of Engineering, and also the provincial funding from Alberta Innovates, and federal funding from Canada First Research Excellence Fund. So with that, I like to stop and I'll take any questions you might have. Maybe I can stop my share.
Thank you very much, Professor Kibia. Well, audience, please give Professor Kibia a round of applause for the challenging and attractive presentation. And we already learned a challenging method to add the value of CO2 by converting into functional chemicals such as methanol. Ladies and gentlemen, recently Professor Kibia already developed the synthesis of renewable feedstock and fuels, and some of them were already published in reputable scientific journals like Transition Pathways Towards Net Zero Emissions Methanol Productions is published in Green Chemistry. The next is Can Sustainable Ammonia Synthesis Pathways Compete with Fossil Fuel-Based Haber-Bosch Processes is published in Energy and Environmental Science and many more distinguished research papers. Ladies and gentlemen, for those who are enthusiastic to raise questions for Professor Kibia, you are pleased to use message tab of this Zoom link or YouTube, or raise your hand for direct questions, and Professor Kibia would be happy to answer directly. We have 25 to 30 minutes for question and answer, and I open on the first session of Q&A, and each may consist of 2 or 3 questions. Please deliver your short and concise question to the speaker, and before delivering, please mention your name and your institution. I open the Q&A session.
And apologies for going so fast because there are a lot of materials I wanted to share, but maybe another day, because there are a lot of things going on in the lab, and there are about 15 group members, including some PhD students, master's student, postdoctoral fellow, and they are working on different aspects from catalyst development to all the way to system analysis. So the group is quite diverse, but yeah, I like to hear any questions you might have.
Well, is there any other opportunities for working in your laboratory as well now?
So right now, yeah, I'm always looking for potential like motivated and hardworking students or researchers. So if anyone is interested, feel free to reach out. Sometimes we have some limitations in terms of funding. It's easy if you have your kind of some sort of support from the government or some other source. But if not, there are still some possibilities. It depends on the grant applications and all these things. But yeah, welcome to just send me email anytime, and I'll be happy to have a conversation on that.
Thank you very much. Ladies and gentlemen, any questions so far? Hello? You may raise your hand, or you may text your questions in the message board. While waiting for the question, I would like to ask you a short. I would like to ask you short questions. Yeah. Well, in the future, CO2 would be precious chemicals. What do you think? Is that right? Because we can use it as precious chemicals, yeah, as raw materials.
Yeah, I mean, this is one of the ways of decarbonizing our system, right? So better would be to avoid doing any kind of activities which would generate CO2. But we have lots of CO2 in the air that needs to be kind of captured and find a way to sequestrate it. So sequestration is probably one way to avoid this climate or global warming and so on. But at the same time, CO2 sequestration may not be the solution for everyone. For example, in Canada, in Western Canada specifically, we have geological formations where we can store CO2, but that may not be the case for other countries. So I don't see there is a kind of one solution to the problem. So there might be different ways, and we really need to put together all efforts. If we really want to think about our climate, we think about our environment. So that is very important that we look into all the opportunities, because this is a problem we are talking every day now in political debates and everywhere we are talking about. But how much work we are doing, is that enough or not? So the rate of kind of CO2 emission is quite high now, and if we do not take actions, then we'll be in a situation that there will be no way out. So we really need to think about innovations in this aspect.
Well, okay. So do you think that fossil fuel does not matter anymore in the future after several remarkable innovation now?
Yeah, I mean, fossil fuel, we cannot ignore it, right? So definitely, we rely on it today. But the faster we can get rid of it, maybe, let's say in 10, 20 years, we might be still using fossil fuels, but slowly we have to stop depending on it, right? So, so that's the thing. For the countries where they have lots of fossil fuels, they want to extract it, but the challenge is we need that from one side, because we do not have alternative solution, right? So if we have alternative solution, for example, renewable electricity, then people will be relying more on that. But we don't have that solution. That's why we keep exploring our what we have in the ground, right?
Okay, thank you very much, Professor Ribia. Now the time is your audience. Do you have any question? You may text here in this Zoom link, or you may raise your hand for raising the question. Do I have any question here?
Well, it was too easy for everyone, so they don't have.
We open the question and answer for about 20 minutes. So we have 15 minutes more for any question, 1 or 2 questions. The declining cost of renewable energy is very, very important issues here, because the technology is expensive now. But what do you think about the raw materials such as biomass? You know that the biomass is also a promising renewable energy resources, but you in Indonesia, you know that although the biomass now is priceless, but in the future it may the cost may increase, and the trend is increasing now. Yeah.
No, I think for biomass, I see opportunity, because and that's why we're working on biomass here. In Canada also, we have lots of biomass. And first of all, the good thing about biomass that they are carbon sink. Right? They can capture a lot of CO2. So that is true. On the other side, what can we do with the biomass apart from just capturing CO2? Can we find a way to make some of the biofuels that we are talking about, right? For example, bioethanol is one good example, or the corn ethanol. So this is one example that bio-based fuel can be quite interesting to have like an additive for the fossil fuel-based fuels. But I think that some of the technologies are still not that mature enough. Some of them are probably, people are working on the pyrolysis and other processes, but in terms of, for example, photocatalysis or electrocatalysis, is still far from reality. So, but this is an important area, I think more and more people are working on. And I really see some value if we can convert biomass to make some biofuels on or for any other applications, like what I showed another example of a bio waste, for example, glycerol. We try to use that to reduce the energy consumption of our CO2 chemical, CO2 conversion process. Yeah, so definitely there are some areas we need to work on, and you are also working on biomass, Professor Sunu. So
Yes.
you do probably better in this area than me.
Well, I work for biomass as to convert into energy. Well, Professor Gibria, it's I believe that actually there are more questions waiting to be confirmed, but maybe they will deliver you later.
Sure, no problem. I mean, I can, if it's not now, but if there is any question, I can answer at a later time as well.
Is it possible for you to share your email or something, or contact?
I can type it in the chat box if anyone need it. Let me write down. This is my email address.
Thank you very much. Thank you very much, Professor Kibria. Again, on behalf of the Icimece 2021 committee, I'm the moderator, would like to express our gratitude for your presentations. We really hope that this moment may initiate our future collaboration, and have a nice day. See you soon, Professor Kibria. See you in the future. Bye, and thank you very much. Do you have any last?
Thank you so much for the organizing committee, and to Professor Sunu and everyone for giving me this opportunity to talk about the work that we have been doing. So it was really an honor for us, for my team and for myself, to present some of our work and some of the activities going on. But I am really looking forward to hopefully in future be able to go there in Indonesia and give the presentation in person, not virtually.
Thank you very much, Professor Kibria. Give a round of applause for him for the presentation, and goodbye.
Thank you so much. Okay, thanks everyone, and have a wonderful day. Okay.
Well, ladies and gentlemen, that was the Professor Kibria's presentation, and now the second keynote speaker is Dr. Koji Enoki of University of Electrocommunication in Tokyo, Japan. Do I have Dr. Enoki here? The commit. Do I have Dr. Enoki here?
Yes.
Not.
I have here.
Hello.
Hello.
Okay.
Okay.
Good morning, Dr. Enoki.
Yeah. So,
how are you?
Oh, fine.
Fine.
Good. So, let's move to my presentation. Is it okay?
Well, yes. Just before presentation, I would like to introduce Dr. Koji Enoki to the audience. Ladies and gentlemen, Dr. Enoki started his career in the University of Electrocommunications since 2015 as assistant professor. He took his doctoral degree in Kyushu University. Dr. Enoki's research areas focus on thermal, fluid, and energy engineering. Some awards are his scientific achievements. For instances, incentive awards of the Japanese Society for Multiphase Flow, and Outstanding Contribution in Reviewing Award from Elsevier. He has granted some intellectual property rights, such as a patent of heat exchanger for a thermoacoustic system. Several publications that I can mention here, for instance, experimental investigation into the heat transfer and pressure drop performance of sintered high porosity media, which can be assessed in Applied Thermal Engineering Journal. Another one is under the title of pressure drop of a refrigerant flowing vertical upward and downward in small circular, rectangular, and triangular tubes was already published in Applied Sciences. In this time, Dr. Enoch Isang, please share us one of his exceptional research under the title of Experimental and Numerical Investigation into the Heat Transfer and Pressure Drop Performance of Sintered High Porosity Media. Dr. Enoch Isang, the time is yours. You have about 30 minutes for presenting. And after that, we have a question and answer session.
Okay. So thank you, Chairman. So let's start my presentation. The title is Experimental and Numerical Investigation into the Heat Transfer and Pressure Drop Performance of Sintered High Porosity Media. So my university is National University and located on Tokyo. And I worked as an assistant associate professor. So the first, I was congratulations to the Professor Budi. So first, I was very happy to hear this news. But however, I think Professor Hagen should be a full professor for this purpose. I will continue our collaborative research. I will continue to collaborate with Professor Hagen, and we will work together to make sure that he become a professor. Wait. Okay. So this slide indicates the relationship history of Professor Hagen, Professor Budi, and Dr. Indri and Miss Imam. We first contact is 2016, and we made a lot of memories, and I went to Indonesia many times, and 2020 before Corona pandemic. So our university and UNS signed the MOU. So this is the memorial picture in Indonesia, Professor Hagen, Dr. Budi, Professor Budi, Dr. Indri. I am doing here. And Imam, Mr. Imam, about 2 hours lecture at UNS 2019. I met Mr. Imam as a student. So the Imam want to be a doctor. So I hope he will come to Japan and study my laboratory, I hope. And just after signing the MOU and Corona pandemic has begun, so Dr. Indri was selected as a JSPS postdoctoral fellowship from April 2020. It was very difficult and only 3 applicants in engineering were selected at this time. Very smart. So I know her since she was a student because I often to go to Kyushu University to do study meeting with Professor Miyazaki. Professor Miyazaki is supervisor of the Dr. Ind. And I hope that it would promote collaborative research with UNS, but it's still being postponed. But maybe next month, she maybe will come to Japan. Anyway, UEC is looking forward to the day when Dr. Indra will be here. So my profile, so my name is again Koji Enoki, and I got the doctor degree from Kyushu University, same as Professor and Dr. Indri. I am an associate professor at the University of Electrical Communication in Tokyo, and my study topic is summer engineering and two-phase flow and heat exchanger and AI, DNN. So I am a PI as Enoki Lab. And my lab has collaborated study with companies and the Japanese government. JAXA, do you know JAXA? JAXA is the head of the Japan's aerospace agency, which operate the space station with NASA. And flight rocket frequency. And our joint research is top secret. And NEDO is the government of Japan's. NEDO and JSPS is Japanese government. And so our collaborate company is Mitsubishi Material and Honda Jidosha and Daikin. And today's topic is supported by JSPS and Mitsubishi Materials. So first introduction, my study is improving the performance of heat exchanger. Heat exchanger used as an important element devices in various machines. And car, air conditioner, PC, refrigerator, and so on. And the problem with heat exchanger is air side heat transfer is very, very low compared with water and freon boiling. So the introduction, the minus 20 Celsius of LNG used for the summer power generation and exhausted heat from factories below 20 degrees disposed of into the ocean and atmosphere. The amount of energy that disposed of exhaust from factories after import fluid reached 5%. In addition, the heat from automobiles, gas water heater, cargo ship, and other source of primary energy is disposed. More than 60% of summer energy is disposed. Breakdown of Japanese energy consumption this year, 26% is thermal power station made electrical energy, and over 70% other car and so on. So again, 6% of summer energy to be wasted. If this energy could be recovered and used effectively, less than half of the energy would be sufficient. So importance of research and development of exhaust heat recovery. In other words, research on heat exchangers is very, very important. Reason why exhaust heat has not been used so far, because waste heat is essentially a fluid, often a gas. So the heat transfer coefficient, this heat transfer coefficient, the ability of transfer heat of a gas is very, very low. Example of the personal item that utilize the low heat transfer coefficient of gas. So bedding, thermal protection, and sauna, 100 degrees Celsius, but no burns because the gas is very low heat transfer coefficient. And do you know Fusuma? Fusuma is Japanese sliding door, and shut down outside hot air or cold air. So since waste heat is also gas, it requires a huge amount of land and material cost to recover, and is not cost effective. Why did I start researching heat transfer enhancement in gases? And I got a request from a company and a university for waste heat recovery. And this is the shell and tube heat exchanger. Shell and tube heat exchanger is a heat exchanger, one of a heat exchanger with mini tubes that prevent two fluid that want to exchange heat from mixing with each other. The actual heat exchanger that was used, and this is the picture of the shell and tubes. Japan imports LNG in liquid form, but when it vaporized, the cold energy is dumped into sea. So then, if it could be recovered, it could be used for air conditioning and cooling, thus saving energy. However, due to poor heat transfer on the gas side, this gas side, so LNG cannot be vaporized at all. So this heat exchanger is aiming for 1,000 watt, but only 100 watt of heat can be recovered. In other words, heat transfer on air side was too poor. So I was very confused when I heard about this. This was crazy request. So request is the branch standard not to be changed. So but we want to they want to achieve 10 times the heat exchanger about gas side. So, for example, the speed of motor bicycle of 30 kilometers is not enough. They want me use the same engine and they increase the speed 300 kilometers, which is the same as the takeoff speed of airplane or Shinkansen. So this system cannot be changed, but I can go the 10 times heat transfer, heat amount. So discussed about new type heat exchanger. I and Mitsubishi Material discussed about new type heat exchanger. Then new type heat exchanger is born. This is conventional tube, and this is new type heat transfer tubes. This tube, new type, looks very densely packed, but it's very sparsy. Only 20% of the space is occupied by metallic fibers. They are randomly arranged and appear to be densely packed. Then the pressure drop is very, very small, about 0.7 kilopascal if 25 millimeter packed. Heat transfer tube and material fiber sit together. So minimum, we can get the minimum heat loss. Since it is made of pure aluminum, so very, very light, you know, so can be installed anywhere and export in huge quantities. And resistant of low temperature fragility, not broken. So first experiment with single tube. And this is an experimental apparatus, and this is the filter inlet of the air atmosphere. After the air is compressed and dried, and two air tanks are provided to maintain a stable flow rate. In addition, since the compressed state has high density air, so we can use caloriflow can be used in this way. It is possible to measure the mass flow rate with high accuracy. And the lava, silicon lava heater is used to heat the dry air, which almost the atmosphere temperature about 25 degree to 200 degrees Celsius. The air is then flow into porous media pipe. And this porous media outside of the tube is double tube structure, and the pressure is controlled so that isobutan is boiled and cooled at 5 degrees Celsius. So notice it took 3,000 millimeter of heat transfer tube to raise the temperature of 25 degree dry air to 100 200 degrees Celsius, and experimental parameter porous filling lengths of 25, 50, and 75 millimeter. Result, so global breakthrough has occurred that Bhutan's convention wisdom on heat exchange. The upper triangle indicate the inlet temperature, which 200 degrees Celsius. The lower triangle is the outlet temperature, and the black color is 0 millimeter. 0 millimeter is conventional tube. And a temperature difference of 107 degree Celsius could be obtained by filling the tubes only 25 millimeter, while the conventional tubes could only obtain temperature difference of about only 50 degrees Celsius. So almost 100% perfect of the summer energy of 20 degrees Celsius dry air was successfully recovered. The best feature is the temperature was raised from 25 degree to 200 degree at 3,000 millimeter. But the temperature was successfully recovered at only 25 millimeter with porous fills. So only 100 times less. So the result of experimental as a shell and tube heat exchanger. Yes, we experiment with heat exchange between liquid nitrogen and air to see if it could actually be used for cooling. This is the convention. This is the I made one. So compared with conventional and my study, its material is different, and inner diameter tubes is this is 6 millimeter and 107 number of heat transfer tubes have. But my studies heat exchanger is only 30 heat transfer tubes, and weight is this conventional shell and tubes is almost 30 kilogram, very, very heavy. But this heat exchanger is 4.4 kilogram. So then the 0.34 times less than the conventional heat exchanger. So we can install this heat exchanger easily because the weight is very, very low. And the design heat transfer rate is 1,000. So output value is 100, only 100. But my heat exchanger is 1,600 watt. So 16 times the heat transfer amount we get. So yes, as I said earlier, for example, with 30 kilometer motorcycle engine, and the same engine we use and the request achieved 300 kilometer, but we can get the 480 kilometer. It is enough and succeed. Recently, I have also been working on simulation analysis. We have increased the inlet temperature is 300 degrees Celsius, and the result the same as the experimental values. This simulation analysis is based on the CT scan of a porous body, and of course, since it is CT scan, I can obtain some fluid information from all angles, just like the body. However, I cannot show the cross-section image because it shows the structure of the body, and I am not allowed to show it is due to the patent issue. The change in temperature and pressure obtained from simulations show the same value as the experimental value. In other words, we can now understand any fluid even if we change the size, change, and heat transfer tubes without doing any experiments. By the way, the price of this simulation software is $1,500 Japanese yen, almost 2 billion Indonesia current. So this is very expensive, but the simulation speed is perfect. So acknowledgement. So this work was supported by JSPS, Kaken, and Mitsubishi Materials. In addition, thanks for my lab collaborators. Thank you. More detail, please visit my lab website, and English is allowed. Please access from this QR code. Thank you.
Well, okay, thank you very much, Dr. Inoki. What an impressive innovation, and let's share our applause for the remarkable presentation. Well, Dr. Inoki, I'm happy to meet you here in this conference, and I believe this is our first meet between you and me, isn't it? Although you frequently visited our university. And absolutely, you're familiar with Universitas 11 Maret, and this is not your first participation in an international conference organized by this university. Okay, I'm sure that many are waiting for this moment. It is a Q&A session. Everyone here may text message for questions in this Zoom link or YouTube channel. It is also possible for the audience to raise the question directly by raising your hand, and please let us know your name and institution. We have about 20 to 30 minutes for Q&A session, and I open the first session for 2 questions. Okay, yes, I'm waiting for the question. Dr. Enoki, please is to answer your question. Do I have question here? Well, Dr. Enoki-san, the heat transfer and pressure drop are also the research areas in chemical engineering. I'm from chemical engineering. Then it is an opportunity to enhance the collaboration between chemical engineering as well and your industry in the future.
Yes, of course. But so please ask the professor and Professor Budi.
Yeah.
Okay.
Well, we know Professor Budi. Well, everyone who are chemical engineer here is as possible to initiate a collaboration with Dr. Enoki in the research area of heat transfer and pressure drop. Do I have a question for Dr. Enoki? Anybody would like to raise a question? Please unmute your mic and let us know the name and your institution if you want to ask. Okay. Mr. Agustami Sitorus.
Okay, thank you, sir.
Yeah.
Okay, thank you for time for Professor Suno. Thanks for presentation of Sensei Enoki. It's an impressive presentation. Let me introduce myself. My name is Agus. Actually, I'm Indonesia, but now I'm studying Kim Mokon Institute Technology Lat Krabang in Bangkok. I want to know about how cost production heat exchanger you develop. And can you explain step by step how the manufacturing it?
How to manufacturing?
Your development exchanger. Step by step. It's more cheaper or sometimes expensive. I think it's only my question. Thank you, Sensei Enoki. And thank you, Prof. Suno.
You're welcome.
You're welcome. And this, how to make this heat transfer tube is, I want to talk about the patent issue. So I cannot tell you about this. So sorry.
Oh, it's still a patent, Sensei Enoki?
Yes, my patent. My
patent it was granted.
What?
Or registered?
Register?
Or register, okay.
Well, unfortunately, Dr. Enoki, sorry for the share his patent. Well, it is a proprietary right, yeah. So
okay.
Hopefully that you understand his right. Thank you, Mr. Sitorus.
Thank you.
Okay. Well, we have here Dr. Inayati from Chemical Engineering Universitas 11 Maret. Your time, please. A question from Dr. Inayati to Dr. Enoki, yeah?
Okay.
Thank you very much. Thank you very much, Mr. Suno. Question for Prof. Enoki regarding the fluids used for the testing the device. If I'm not mistaken, the combination of the fluids is dry air and isobutane. Have other fluids being used for the test? And the reason why we use isobutane for testing the device. Thank you very much.
Yes. So that's problem is will be occurred. So your question is right.
The question is, was there other fluids used for the testing other than the isobutane?
Isobutan.
If the device is tested using other fluids.
Oh, yes, yes, of course, of course. So the only use this why I use the isobutan. So the saturation temperature control is very easy. So I was used the isobutan, but so we use the any fluid, cooling fluid we can use, of course.
Also have been tested using other cooling media.
Yeah.
For example?
Oh, for example, so LNG, LNG is okay, and liquefied nitrogen is also okay. So because all this tube, this cylinder tube is all made from aluminum. So the low temperature, if the low temperature
fluid
flowing, but so not broken.
Okay. Thank you very much.
Thank you very much, Dr.
Sure.
Inayati. Well, Dr. Inoki-san, Dr. Inayati is the lecturer of transport phenomena in chemical engineering department, and I believe that he is also an expert in heat transfer and mass transfer area in chemical engineering side. Well, okay. Do I have another question here? Somebody would like to raise the question for Dr. Inoki? Let me check first. Again, Dr. Inayati, you want to ask again? Ask another question? As you raise your hand?
No, sorry.
No, it's enough. Okay, thank you. Do I have here another question? Well, my question, Dr. Inoki.
Yeah.
Using the porous media inside the tube to increase heat transfer is very impressive. And anyway, I would like to know how to do maintenance, especially when we use liquid or gas which contains some solid impurities, because it is possible the impurities may deposit in the porous media. How can we do if it happens? Do you have any suggestion for maintaining or for cleaning? Do you have to take all the media out from the tube or something?
So your question is maintenance?
Yes.
So this this is the very cheap, not not expensive and cheap, and very weight is very light. So the maintenance is very easy.
Oh. So we may reuse the media after maintaining, or we have to replace with a new one for the next operation.
Next question is, okay, one more, please.
Replace. We have to replace the media if it's there is a deposit.
Replace also easy, because this it the wait. This France is the standard standard manufacturing. So we can design the if you want to be installed, if you want to be installed about any devices, this heat exchanger is easy to install. So the designing this heat exchanger is very easy.
Okay, then
and very small.
Yeah. And it's just a simple maintenance and cheap.
Oh, yes.
And the media as well, yeah. The porous media as well, yeah. It could be manufactured by, let's say, by any workshop, yeah.
Yeah. The length is almost the thumb.
Okay. Thank you very much. Well, ladies and gentlemen, we have 10 minutes more for question and answer for Dr. Inoki. Any more question? You may raise your hand and unmute your microphone.
Professor Agung?
Yes. No more question? Well, okay. Ladies and gentlemen, I believe it was a fruitful discussion. And if you want to know more about Dr. Inoki research in heat transfer and pressure drop areas, you may also contact him directly via the email. Is it okay?
Not directly. So please ask the Professor Agung and Professor Kuri. Because UEC office in there is a UEC office at the UNS.
I see. Okay. Well, I believe that I have Professor Budi and Professor Agung Wijayanto here.
Yes. Thank you. Yeah.
He will be glad to answer any question about heat transfer and pressure drop on behalf of Dr. Inoki. Thank you very much, Dr. Inoki. I have to end this session now. Anyway, Dr. Inoki is very pleased also to answer your question later. Thank you very much for your remarkable presentation. And on behalf of the committee, I would like to convey you our gratitude for your participation. Have a nice day, Dr. Inoki. See you later and good morning. Thank you very much.
Thank you very much.
You're welcome. See you later.
See you later.
Thank you, Enoki Sensei.
Oh, thank you.
We have Professor Agung Triwijayanto here.
Yeah.
You have to greet Professor Enoki.
Yeah.
Okay. Thank you. Well, ladies and gentlemen, now it is the time for me to resign as moderator here. Oh, thank you very much for your participation and stay healthy. Miss Dwayanti and Miss Damayanti, the time is yours now. I'm resigning now. Thank you very much, ladies and gentlemen, and see you later. Assalamualaikum.
Waalaikumsalam.
Thank you very
Thank
much.
you. Okay. Thank you, Dr. Suno, for your smooth and pleasant leading the session. And thank you for Dr. Kibria and Dr. Enoki for your very insightful speech.
Move right along. The next keynote speaker sessions will be moderated by Mr. Ferry Adrianto, PhD. Before we hand out the sessions, please allow me to give you a brief introduction of our moderator background. Mr. Ferry Adrianto, PhD, was born in Indonesia in 1968. He received the PhD degree in microelectronics from National Cheng Kung University, Taiwan in 2014. During 2010 until 2013, he joined Microsystem and Nanotechnology Lab, University of Oslo, Norway as a visiting PhD student for work package 4, New Materials for Next Generation Solar Cells. This research is part of the FME, Norwegian Centers for Environmentally Friendly Energy Research project to further develop Norwegian photovoltaic industry. Since 2015, he has been with Microelectronics and Nanotechnology, Shamsuddin Research Center, University Tun Hussein on Malaysia, where he is a postdoctoral researcher. His main areas of research interest are nanomaterial for thin film transistor and solar cells. Mr. Ferry Adrianto, PhD, is also head of department at Department of Electrical Engineering, 11 Maret University, Indonesia. Without any further ado, ladies and gentlemen, please welcome Mr. Ferry Adrianto, PhD. I'm sorry, Mr. Ferry. Is this mute?
Okay, test. Do you hear my microphone?
Yes, Mr.
Okay, thank you very much. Okay, yeah. Okay, good morning. Assalamualaikum warahmatullahi wabarakatuh. Welcome to the keynote session, the third and the fourth of the keynote session of Icimece 2021. My name is Ferry Adrianto, and I am the moderator for this session. We will be hearing a presentation from Professor Madya Insinyur Dr. Syed Satir Ashar Syed Hasan from School of Chemical Engineering, University Teknologi Mara, Malaysia. Before we get started, I wanted to take a few minutes of the time. The presentation time for keynote speaker is totally 50 minutes, with 30 minutes for talk, 20 minutes for Q&A, and 5 minutes for moderator and keynote speaker suites. Yeah. For the discussion, please raise your hand, open mic, or write the question by using the chat button. Okay, I will introduce of the speaker for this session. Professor Madya Insinyur Dr. Syed Satir Ashar Syed Hasan received the diploma degree in industrial chemistry, University Teknologi Mara, Malaysia in 2001, and then Bachelor of Engineering with honors degree in chemical and process engineering from University of Newcastle upon United Kingdom in 2003, and also received the PhD degree in chemical engineering from Curtin University, Australia in 2011. His research interests and expertise on energy and fuel, catalysts, carbon materials, thermochemical conversion, and absorption. Now he is a director, Business Innovation and Technology Commercialization Center, BITCOM, at University Teknologi Mara from March 2021 until now. I would like to welcome our presenter. He will deliver a presentation with the title Iron-Loaded Activated Carbon as a tar cracking reformant catalyst in the production of clean producer gas from oil biomass. Prof. Satir Asad Hassan, are you here in the Zoom?
Yes, I'm here.
Thank you. Assalamualaikum, Prof.
Waalaikumsalam.
How are you today?
Good. Yusuf.
Alhamdulillah. Yeah, Alhamdulillah.
Good.
Yeah, nice to meet you in this beautiful day, Prof.
Yeah, nice to meet you too.
Yeah, thank you for coming to this presentation.
Yeah.
Okay. Well, ladies and gentlemen, please welcome from Professor Madya Engineer Dr. Satir Said Hassan. The 30 minutes for clock. The floor is yours.
Okay. Thank you very much, Dr. Ferry, for the kind introduction. And I would like to also thank the organizer for our Icimece 2021 for inviting me to speak in this conference. Right. Let me share my presentation slide. Okay, can you see the slide now?
Yes. Yes, I can see. Okay, please.
Okay. Right. So my presentation, the title of my presentation today is the iron-loaded activated carbon as a tar cracking or tar reforming catalyst in the production of clean producer gas from oil palm biomass. Okay. I would like to start by showing you the world's energy production trend. Yeah. So if you can see in the slide, our world is basically still depending very much on fossil resources for energy production, from coal, natural gas, and from oil. Although we can see some decreasing trend in terms of oil consumption, and we can also see the consumption of coal also start to show some decreasing trend also. But the natural gas consumption is increasing. Okay, so this is due to the fact that natural gas is much cleaner than coal and natural gas. But overall, the contribution from the non-fossil resources is still very significant, more than 80% of the total shares of our global primary energy. And more importantly, we will look at the contribution from the renewable resources. Although there is an increasing trend in the production of renewable energy, but in total, the contribution of the renewable is still quite low, which is less than 10% of the shares of the global primary energy. And if we look at the renewable energy production, as we can see here at the beginning, in the early 2000, most of the renewable came from geothermal, biomass, and other renewable resources. But this category of renewable resources, if we can see from year to year, the changes is not that much. Although there is an increasing trend, but the changes is not that much as compared to the wind and solar energy production, which increased tremendously. Yeah. Anyway, if we look at our renewable resources, we have wind, we have solar, hydro, geothermal, and biomass. Among these resources, only biomass that can provide hydrocarbon molecules similar to what the fossil does. This means that biomass is the only renewable resources that we can say a versatile resources, which can not only provide us energy and power, but can be utilized in the production of different types of chemical, liquid, transportation fuels, and other materials that society needs. So this means that the area of biomass conversion is still very much significant and relevant to us today. Especially for Indonesia and Malaysia, where we are quite lucky to have abundant supply of biomass throughout the year, especially from the oil palm businesses and the palm oil businesses. Yeah? So if you look at the oil palm plantation, if we could take the oil palm trees, yeah, so only 10% of the oil palm trees will contribute to the production of palm oil, while the rest of the trees is considered as biomass in different forms. For example, we have fronds and trunk at the plantation site, and we have empty fruit bunch, palm kernel shell, and mesocarp fiber at the oil palm mill, which altogether contribute to the production of more than 100 million tons of solid biomass every year, both in Indonesia and Malaysia, which means that there is big potentials for us to exploit these massive biomass resources to produce high value products. Yeah, so not only utilizing the biomass for the low value products, but we need to aim to produce the high value products from this vast amount of biomass resources. So biomass conversion is one of the area of research that has been pursued by many researchers throughout the world. So the idea is to do the same thing as what the fossil does, yeah, because fossil is actually originated from biomass anyway, but it takes millions of years before it can be useful to produce fuels, chemicals, power, and materials. So in the biomass conversion, our aim is to reduce the million of years to 0 year, yeah, utilizing different types of technology to produce fuels, chemical, power, and materials from the biomass. And generally, we can classify the biomass conversion into two major conversion platforms, which is the biochemical conversion and thermochemical conversion. For the biochemical conversion, we have digestion, for example, to produce biogas. We have fermentation to produce bioethanol. Yeah. For thermochemical conversion, we have the pyrolysis, which can be tailored either to target the production of bio-oil, or we can also target for the production of biochar. Yeah. And then we have the gasification that can produce syngas, or we call it producer gas. And we have the traditional combustion, yeah, direct combustion of biomass to produce heat in order to generate power or to produce steam at the plant. Yeah. And then we also have other processes within the thermochemical conversion platform, which is quite similar to the pyrolysis. For example, we have torrefaction, we have carbonization, and we have liquefaction. So the interest of my research group is more on the thermochemical combustion rather than the biochemical combustion. And for this presentation, particularly, it is more related to the gasification of biomass. Right? So what is biomass gasification? Basically, biomass gasification is the process of converting our biomass materials into a gaseous mixture, which consists mainly hydrogen and carbon dioxide, but also it contains methane and CO2. Yeah? So this gas mixture can be used to produce heat and power through different types of application. For example, we can use gas turbines or internal combustion engines or fuel cells. And the gas mixture can also be utilized for producing different types of chemical. For example, we can use the Fischer-Tropsch synthesis to produce liquid fuels. And the gas mixture can also be used to produce methanol, dimethyl ether, and many other chemicals. And at the same time, the syngas can also be used in the biochemical fermentation to produce different types of biofuels, biochemicals, and biomaterials. Yeah? So we go further into the biomass gasification mechanism, right? Gasification, yeah, for those who background is not in biomass conversion, I will introduce a little bit about the gasification mechanism. Gasification basically is a two-steps process. Yeah? In the first process, we have the pyrolysis process, or we can also call a devolatilization process. And pyrolysis is basically the initial step in any thermochemical conversion, be it combustion, gasification, carbonization, or liquefaction. They all start with the first step, which is pyrolysis. Yeah? So basically, pyrolysis is a process whereby our biomass material being decomposed due to the action of heat. Yeah? When we introduce our biomass into the reactor, which is operated at high temperature, the first step is the thermal decomposition of biomass and also the vaporization of biomass moisture. So this step will generate volatiles and char. Basically, volatiles consist of light gases, for example, hydrogen, CO, CO2, and methane. And we have steam, which came from the biomass moisture, which is being vaporized inside the reactor. And at the same time, we also have the heavy molecules that we call tar. While for the char basically is the solid residual from the thermal decomposition of biomass. So they consist of the organic parts of the biomass and also the inorganic parts of the biomass. So if our target is to produce bio oil, especially by fast pyrolysis, what we want to do is we want to condense as soon as possible this volatile so that we can have maximum yield of bio oil. Yeah? So that is for the pyrolysis, yeah? Especially the fast pyrolysis. But for the gasification, our aim is not to obtain the liquid products or the solid products. Yeah? Our aim is to obtain as much as possible the combustible light gases. So what we do in the gasification, we allow the volatiles and the char to further react in the reactor. Yeah? So the volatiles, especially the tar, can further undergo the thermal cracking, yeah, to be cracked to smaller molecules inside the reactor. And at the same time, we introduce the gasification agent into the reactor. So gasification agent can be steam, can be air, or can be CO2, or the mixture of this. Yeah. So other than tar cracking reaction, we also have the gas reactions taking place, which is the reaction between the gasification agent and the volatile components. And we also have the gas solid reactions, the reaction between char with the gasification agent and reaction between the char with the volatile component. So at the end, we will have the maximum yield of combustible like gases. That is the aim of the gasification. So now we have the producer gas from the gasification. So what's the main problem in gasification is that, right? Although I show that we allow the volatiles to further react in the reactor, but unfortunately, not all the tar components will be transformed to smaller molecular weight products because some of the tar components are very stable. It's very difficult to react. So they remain in the producer gas. So this will give some problem to us, yeah, especially when the concentration of tar in the producer gas is very high. This will cause different types of problem. For example, it will cause fouling and blockage in the piping system and also in the downstream equipment, which will lead to the operational disruption, and this will also cause high maintenance costs. And on top of that, yeah, when we have high tar concentration in the producer gas, another result of this is that we will have a lower gas yield. Yeah, so because not all tar is converted to the gas, meaning that not all the biomass components is converted to the gas, give you a reduced gas yield. And the gas that we obtain also will have a lower heating value. Yeah? And the high impurities in the product gas will also reduce the combustibility of the gas. So basically, different types of application has set a limit for tar concentration. For example, compressors requires that tar to be limited at 500 milligram per normal cubic meter. For internal combustion engine, which is our target to be used in this project, the ICE requires tar to be not more than 100 milligram per cubic meter. And if you look at the gas turbine, it's even lower, requires 5 milligram per cubic meter, and fuel cells require less than 1 milligram of tar per cubic meter. So this means that gasification that we carry out must produce high quality of the gas in order to be useful in the downstream application. Yeah. So to achieve the high quality syngas, firstly, we need to produce high gas yield, and the gas that we produce should have a suitable gas composition, should have low tar concentration, and also must have low content of impurities. Yeah? So there are several ways we can use to reduce the tar in the producer gas. For example, we have physical processes like absorption or filtration. And then we have thermal cracking, and also we have the catalytic process like catalytic tar cracking or catalytic tar reforming. Yeah. So the studies have shown that the use of catalysts have proven to be beneficial for the gasification in terms of economic point of view. And the use of catalysts has been shown to be able to improve the quantity and the quality of our product gas. It will also lower the gasification temperature condition, and it is capable of converting the tar into gases. This is the advantage of catalytic process as compared to the physical process, because physical process can only reduce the tar in the producer gas. It just remove the tar from the producer gas, but it does not contribute to the additional production of light gases. So this is the advantage of the catalytic process, because it will also improve the gas composition. Yeah, and unfortunately, most of the catalysts can be easily deactivated during this gasification process. So it is important to develop a low-cost type of catalyst that have reasonably high catalytic activity in the cracking or reforming of the tar. So in the past, there are several types of catalysts that have been used. For example, noble metal is very excellent performance, but it is expensive and not practical to be used in a big scale application. And then we have dolomite, very low cost, but it is fragile and not stable at high temperature, which means that it can be illiterated out from the reactor, especially in the fluidized bed condition. And then we have the alkali and alkaline earth metal, which is also quite costly and also contribute to another problem, for example, high ash production. Yeah? And then we have the nickel-based catalyst that is easily become deactivated by the deposition of coke on the catalyst. So researchers are now looking into a different alternative, which is a low-cost type of catalyst. So what people are interested now is to use char as a catalyst or as a catalyst support. Char is the side product of the pyrolysis and gasification. It is a very cheap material. Even the char itself have the catalytic activity, because it consists of the inorganic materials, especially the AAEM, alkali and alkaline earth metals, that it is inherited from the parents' biomass. So in the past, there are several ways in which researchers produce the char-based supported catalyst. In the first method, we ion exchange the biomass to have a metal-loaded biomass, and then this metal-loaded biomass is being pyrolyzed and gasified to get the char-supported catalyst. But the char-supported catalyst produced by this method, it has, even though it shows that the metal is very well dispersed in nano-sized particles on the char matrix, but the problem is the amount of metals being loaded is limited and quite difficult to control. So in another method, we convert the biomass to char first by pyrolysis, and then the char is mixed with metal oxide by mechanical mixing. And again, the problem is limited to the amount of metals being loaded to the char, because the attachment of metal only occurs at the outer surface of the char. And then in the third method, we can impregnate the char inside the impregnation solution to get the char-supported catalyst. But still, because of the lacking of pores in the char, so we have a limited amount of metals that can be loaded into the char. And another method is to activate the char first to become the activated carbon, and then only we impregnate with the metal solution to produce the AC supported catalyst. Although this is quite promising because activated carbon has higher surface area as compared to the char, but if we use the high concentration of metal solutions, in order to get a high loading of metals on the activated carbon, we still face some problems of the agglomeration of metal particles on the activated carbon. So this will reduce the surface area of the catalyst, and this will lead to lower catalytic activity. So what our group is currently proposing is to use stepwise impregnation of iron into the AC instead of using the one-step impregnation. For example, if you want to obtain 15% weight iron on the AC, we do it stepwisely. For example, we can do 5% weight every time before it reach the 15% weight. And the results of our study shows that the stepwise impregnation can help improving the dispersion of iron on the AC as compared to the one-step impregnation. So this is the 5% weight at a time method. But when we change to maybe 3% at a time, or 2% at a time, and 1% at a time, the improvement is more significant. But for the result that I've shown here, this is from the 5% weight at a time loading of the iron. Anyway, this result prove that if we stepwisely impregnate the catalyst, this will help us to achieve a high loading of iron without severely deteriorating the catalyst properties. So we have tested our catalyst in the lab scale bio-oil reforming reaction. So we have a lab scale reactor. This is the bio-oil reforming reactor. So we can place the catalyst inside this. There are several tubes in the reactor, right? So what we found that well, without the catalyst, even if we increase the temperature from 700 to 850 degrees C, the amount of tar is still very high, more than 400 milligram per cubic meter in the producer gas. And then when we use the fresh activated carbon, this is fresh activated carbon. It comes from coconut shell. CS means coconut shell activated carbon. We can see some improvement in the tar reduction. So it means that the inorganic components in the activated carbon act as the catalyst to reduce the tar concentration, but still we cannot achieve the target of 100 milligram per cubic meter, which is our target in this case, because we want to apply it for the internal combustion engine. So we increase the loading of iron from 5, 10, 15, and 20 weight %, and we found that by increasing the iron loading on the activated carbon, we can have a better reduction in the tar, and we can also obtain a better gas composition, especially the hydrogen production is improving, but only to a certain extent, because if we load too high amount of iron, which is at 20%, different types of reactions taking place that promote the formation of CO2. Although overall the tar reduction will be better, but in terms of the gas composition, we will have more CO2 here. So we need to be balanced between tar reduction and also the composition of the gas. So 15 weight % would be the best amount of catalyst that can be used in the tar in the bio-oil reforming. And we have compared the catalyst that we produce by stepwise impregnation with the one-step impregnation. And we can see that the stepwise impregnated catalyst shows superior performance as compared to the one-step impregnated catalyst in terms of the gas composition and also in terms of the coal gas efficiency. Yeah? And in terms of the tar reduction, we can also see very clear difference here. For example, at 800 degrees C, with the one-step impregnated catalyst with the same amount of ion loading, we still have quite high concentration of tar, which is more than 200 milligram per cubic meter. And the color, you can see very clear, it's still dark, yeah, as compared to the stepwise impregnation. Our tar solution is almost colorless. It means that it gives a good reduction of tar in the producer gas, and the amount of tar is lower than 100 milligram per cubic meter, which is what we are aiming for, right? And we also tested our catalyst in the pilot scale biomass gasification. Here we have the downdraft gasifier, okay? And after the downdraft gasifier, we have the multi-tubes catalytic cracker, which we put the catalyst inside the tubes. And then after that, we have physical process, cyclone, water scrubber, and then we have carbon bed filter. Yeah. And we have different location for gas sampling. Okay. So O1 is the outlet of the gas directly from the gasifier. So meaning that the outlet at O1 is not being catalytically reacted. Yeah? And then we have O2 sampling points where the gas here is already being catalytically cracked inside the catalytic tar cracking reactor. And finally, we have the O3 sampling at the end of our process after it goes through the physical process of cyclone, water scrubber, and carbon bed filter. And what we found in our study, right? So in the outlet 1, which is directly from the gasifier, the amount of tar in the producer gas is quite high, which is more than 600 milligram per cubic meter. And the amount of hydrogen produced is also quite low, and also the CO production. And then at the O2, this is the tar composition or tar concentration at the O2. We can see that with the catalytic cracking, the concentration of tar reduced significantly, 88%, from 600 to 70 milligram per cubic meter. And we also can see that the combustible gas production also increased quite significantly compared to the one without the catalytic cracking. And finally, at the O3, we will get a more reduction in terms of the tar. Okay, so meaning that with a physical process, we will reduce more to 95% reduction of tar, and the concentration now is 32.54, which is quite reasonably low. But in terms of the gas composition, there is not much different between the outlet after the catalytic tar cracking reactor and at the final exit. So this means that physical process can only help to further reduce the tar and other contaminants, but it does not contribute to more production of combustible gas species. Yeah? So this is also shows that even with only tar cracking reactor, without the physical process, we can achieve the desired tar concentration in the producer gas, which is below 100 milligram per cubic meter. And we also compare our results with the previous studies, and we can see that our gasification system provide coal gas efficiency that is quite high, which is almost 90%. And in terms of the heating value of the gas, also quite superior compared to other studies. Yeah. And we also compare with some other catalysts. Yeah, we show that our catalyst is quite comparable to other catalysts, which can remove 95% of tar. And this is the picture we took from the flare of the gasifier, which shows that the flame color is blue, which indicates that it is a clean combustion, and the gas that we produce is a clean producer gas. So I think that is all from me for this presentation, and maybe we can proceed with the discussion later.
Okay, thank you very much, Professor Madya, Insinyur Dr. Syed Shatir Ashar, Syed Hasan, for addressing this interesting topic. Well, this is the time to do the discussion to get clearer information. The number question of will be limited, so there will be 2 rounds, and each round for 3 questions. Please raise your hand, mention your name, institution, and also your country. Okay. Anybody would like to ask? Please raise hand and open mic. Okay. There is one question from Professor Sunu Hapranolo. Okay, Mr. Sunu, please you are asked to direct to Professor Syed.
Thank you, Dr. Ferry. Good morning, Professor Syed Shatir.
Good morning, Dr. Sunu.
Very impressive innovation. I love it. Well, as my research interest is also on biomass gasification with a different with different area.
Okay.
No problem. It opens my view broader that there is another methods for reducing the tar.
Okay.
Well, I would like to know, are there any gasification facilities already implemented? Already implemented in your country in industrial scale or commercial scale?
For the biomass gasification, with at the industrial scale, we have very limited number. There are a few pilot scale that being developed by the industry, but it is not very much at the commercialization scale, still not operated for the commercial purpose. Most of the pilot scale biomass gasification is at the still the R&D level.
Okay, and what's the gas for? I mean, just for taking the heat, or chemicals as chemical raw materials, or any other purposes?
Okay. Right now, the most of the studies aim for utilizing the gas for the heat and power generation, and because to be used as chemical feedstock, we need a certain composition that is suitable. Yeah. So it requires further purification of the gas.
Okay, very interesting. Well, Professor Satir, thank you very much for your response. And well, it's possible to have a joint collaboration.
Maybe you can share your area of research in gasification.
Yeah.
Maybe we
well,
can
actually, I already applied the gasification system using palm kernel shell. Well, you know that we have also a lot of palm oil plantation there in Malaysia and in Indonesia, and I use biomass gasification for taking the heat by burning the gas, and so I do need very clean gas as long as it has a high calorific value. I need it.
Okay.
You don't need any sophisticated tar reduction. So simple one. I invite you if you want to visit my my facilities.
Okay. Maybe we can find common interest to work with in the future.
Thank you.
Thank you, Dr. Sunu, for introduction to your research area.
Thank you, Dr. Ferry Adrianto.
Okay, thank you very much for the discussion. Anybody question? Please write on the chat button or raise your hand. Okay. Okay. Professor said, based on the previous study that reported that there are several types of catalysts that have potential for cracking of producer gas. Some of criteria for catalysts as follow: they should be easy regenerated. Yes, yeah. Based on this previous study, could you please give a comment regarding the iron loaded in your material?
Okay.
Okay. Yeah.
So usually the catalyst support is made of silica or alumina materials.
Yeah.
So meaning that we can either regenerate it after the catalyst is deactivated, or if we cannot deactivate it, it will become solid waste which we have to dispose of. Yeah. But if we use char as catalyst support, we do not have the problem with handling the solid waste, because we can just burn the char, or we can gasify the char inside the reactor to get additional heat production. So this is much simpler in terms of handling the spent catalyst. So that is why people are now being interested in the use of char as a catalyst support.
Okay. Yeah. Yeah. Okay. Okay. Thank you very much, Professor Seth, for the discussion. Okay. Anybody question? No question. Okay. Okay, ladies and gentlemen, finally we come to the end of the presentation. We would like to say thanks again for Professor Syed Satir Askar Hassan for the informative and interesting talk, and to again for your active participation. We believe this presentation will be beneficial for everybody. And thank you for your attention, and hopefully we will meet in Malaysia, Prof. Seth, or in Surakarta after COVID. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
I'd also like to thank you for University 11 Maret for inviting me. And maybe if anyone interested in my area of research can contact me so that we can find ways to collaborate in the future. Thank you.
Thank you. Welcome. Inshallah, Rob. Okay. Thank you very much. Okay, the next agenda is the fourth keynote session. Yeah. The next keynote speaker is Associate Professor Dr. Somyot Kawit Vilai from School of Engineering King Mongkut Institute of Technology, Lat Krabang, Thailand. Before we get started, is there Professor Somyot Kawit Vilai in the Zoom?
Yes, I'm here.
Okay, thank you.
Yes.
Okay. I wanted to take a few minutes. This presentation will be 30 minutes for talk and 20 minutes for Q&A and 5 minutes for moderator and keynote speaker switch. For the discussion, please raise your hand and write your question by using the chat button. And then I will introduce first for the speaker, Associate Professor Dr. Somyot Kawit Vilai received the Bachelor of Engineering degree and Master of Engineering in Electrical Engineering from King Mongkut Institute of Technology, Lat Krabang, Bangkok, Thailand in 1999 and 2000 respectively. He received the Doctor of Engineering in Mechatronics from Asian Institute of Technology, Thailand in 2005. And his research interest and expertise on power electronic, artificial intelligence in power electronic, power system application, robust and adaptive control, neural network, and fuzzy logic control and mechatronics. Now he is the Dean of Faculty of Engineering, King Mongkut Institute of Technology, Lat Krabang, Bangkok, Thailand. I would like to welcome our presenter. He will deliver a presentation with the title Frontier in AI and IoT Technology to Fight COVID-19, a case study in KMETL, heated humidifier, high flow nasal cannula. Professor Kawit Vilai, the time is yours.
Yes, thank you. Can I share the screen?
Yes, please.
I would like to share my preparing videos of my presentation, and I'm still here, but okay, I prepare some things from the video. Okay, can I now share screen now? Can you see my screen now?
Yes.
Okay, thank you. So, sorry.
Good morning, the distinguished guests, ladies and gentlemen. Today I'm very delighted to serve as the keynote speaker to give the keynote speech on the frontier in AI and IoT technology to fight COVID-19. A case study in KMETL heated humidifier high flow nasal cannula is widely developed from the KMETL, and also we can help many COVID patents. In this conference, it's a very excellent event that I'm very glad to join and to serve as the keynote speaker, the 7th International Conference on Industrial, Mechanical, Electrical, and Chemical Engineering 2021. My name is Somyot Vilai. I'm the Dean of School of Engineering, King Mongkut Institute of Technology, Lat Krabang. My background in the field of manufacturing, smart manufacturing, that use the AI, machine vision, machine learning to make the automation in the industry and also smart manufacturing. So I have been granted get some funding from the government and also many company, the frontier company in Thailand and also out of country For example, Seagate company, Delta, and also Mitsubishi and others that show you in the logo on the top of this slide here. In the past 2 years, have do the research about development of the machines and AI systems to fight COVID-19 as well. For example, the automatic in the intelligent vehicles UVC to use to kill the COVID-19 in the open area and also the coast area as well. So not only help the doctor to fight COVID-19, but we also help the people as well. So the COVID-19 impact to all carriers, all platforms, all fields. For example, the employers cannot go to the factory because you need social distancing as well. And in the case of very dangerous, the factory cannot allow the people to go to the manufacturing. So the fully automations with AI and also fully automation with the smart manufacturing is required. So we can try to make some devices that are intelligent enough to make the systems fully automatic. So it also in the agriculture fields, the smart farm needs for automatic control of environment to help that make the good productivity of the planting of the agriculture sectors. So in the IEEE papers, one IEEE papers that conclude that COVID-19, they need many technology to help and to fight COVID-19. They can divide the sectors that need, like you have the COVID-19, you need the critical features, you need to cut the transmission mechanisms, and also the technology is used in the diagnostics and also treatment, and the last is the preventive measures. So we have technology interventions that need in many kind of technology required for fighting COVID-19. For example, definitely IoT. If you go to COVID-19, you need social distancing, and some cases you need touchless society as well. The touch is the transmission mechanism of the COVID-19 problems. So definitely, if you use IoT or Internet of Things to make the many devices, so the very fast, reliable transmission of the data is needed. So definitely 5G network is really quite important. And also if you're big data, you deal with big data and AI, so you need to manage the data and also the cyber security as well. So the blockchain technology is also required. Definitely AI is also in many of fields of study, including the healthcare, agriculture, manufacturing, and others. So definitely we can say that AI is in all fields and made innovation in devices up to now. Also mobile applications, wearables, and many of technology that need for the social engagement and also social distancing as well. A very important part in the manufacturing is robot technology and also autonomous vehicles, including drone technology as well, are also needed because in the next era of the manufacturing, so not only industrial robot arm can be implemented in intelligent way, but also the moving robot, or we can call mobile robot, and also autonomous vehicle is very quite important to deliver the things from one place to another place with the reliable and safety as well. So before we go into our development KMTR Hype Force, I would like to talking about the Hype cycle for emerging technologies provided from the Gartner, the very big and well-known company, consultant company in the world. So they say that many of emerging technologies are in the phase of innovation trigger and peak already. That's what the meaning. It means that it's not just go to worldwide commercial products, and most of them need 5 to 10 years for development, and some of them need 2 to 5 years for development from now to 2021. For example, you can see for physics informed AI, generative AI, AI augmented software engineering, okay, and etc. These techniques and emerging techniques need 5 to 10 years for development. That means it still have the room or the chance for the researcher to focus on it to make some innovation in this area as well. So some of them need more than 10 years, for example, quantum computing as well. But you see the graph on the right-hand side, as see here, no technology that's already worldwide. Even we have many technology also implemented in commercial product as well, but we can see that it is not worldwide or reliable enough and need many development inside of their product as well. So this graph encourage for all researchers to have the room and have the some improvement for your field in AI, emerging technology, and also IoT as well, or in this case. So focusing on in the AI technology, that again tell that okay, many of AI technology becomes achieved already 2 to 5 years for development. And some of them go to the commercial worldwide. For example, GPU accelerator already in the commercial worldwide already, right? And some of them are nearly to the commercial, for example, machine learning, AI cloud service, and computer visions. You can see that all those technology are also implemented in many products, but they need some development for going to the commercial worldwide. Okay, but also most of them are in the phase of innovation trigger and also the peak of innovation trigger as well. For example, you need to develop the AI marketplace, for example, chatbot and others as well. So deep learning as well, you see, most of technology here, they need 4 to 5 years for development, and also some of them need 5 to 10 years. COVID-19 impact to many things. And in the good side of view, you can say COVID-19 accelerating the digital transforms and new look in many careers. The McKinsey and company, the very well-known, also well-known company in the consulting company. So they propose that many impact of COVID-19 to career in many sectors. In this graph, you can see ICT, ICT, financial, government, educations, and retail trade are also most impacted from the COVID-19 situations. And also the advanced manufacturing as well. On the right-hand side graph, you can see of the extent of the disruptive model of the carriers and also how they use the time for change. You can see in the agriculture, it's not much impact, but in the banking, retail, hotel, and etc. here on the black one here, they need to shape a whole new business. It's very important to focus that if the business changes and demand changes, so the research will change the way as well. Because we would like to do the research that can serve all demands in the world and also all demand in the need of people. Focusing on my country, the Thailand as well, very close to the worldwide country as well. We can see here, like in my country, in AI is a very quite high use case in the future of 10 years, and also data analytics and IoT. Also, based in automation and next generation telecommunication is also require the high impact and also the use case as well as the AI, IoT, and data analytics. The size of the bubble shows the market size. You can see that they are automations and next generation telecommunications are the most biggest of the bubble. That's been very impact to the society of Thailand market. So I would like to say about the medical device that we developed, and today is a case study of KMITL heated humidifier high flow nasal cannula. Our products and our system is past IEC as well. We can plug in for the digital tank, okay, oxygen tank, and feed the oxygen into the machine or the device. And also another side, we feed the air via the HEPA filter and mix it between the oxygen and here the air and filling into the humidifier tanks or humidifier chamber here. So in this case, when humidifiers are ready, they put the airflow with high flow 10 to 60 liters per meter to the patents. And then we have the sensor, many sensor inside this. One of the sensor is flow sensor. Second sensor is oxygen sensor, and the last sensor is the temperature and humidity sensor. All of them are used for making the machines to work well and put the good condition for oxygen therapy for the doctors. So, okay, we can control flow. Airflow can be controlled. And okay, sending the air to the patient and then feedback the oxygen in the blood, okay, back to the machines. Not only the flow can be controlled, but oxygen can be controlled as well. Very good, and the important feature of us is that we can control it by using the touch screen here, or we can control at all parameters setting to the mobile phone application that we developed. And here you can see all data in out of the main devices sending to the mobile. So that means the doctor can be controlled or can be monitor these parameters in any place, anywhere. For example, we change the control of the flow to 41 and the machine change the control to 41 and the flow feed to the patients in the 41 liters per meter. Can control also the oxygens. Can control for 40, 49, sorry, 40. So the oxygen can be changed to 40 as well. Or flow can be changed to 40 as well. Now we can control the oxygen to 63, airflow to 40. So change in the machines by our remote control or remote monitor as well. And the last parameter that we can be controlled is temperatures. And this SpO2 is the feedback of the patients. Okay, this is our KMTL humidified, heated humidified high flow systems that already implemented and already used in COVID-19 cases in many hospitals already. Very important of our development, and we show you the next slide about the medical device standards, IEC 60601-1, IEC 60601-2, that we have collaboration with the National Laboratory to test
For the discussion, please place your hand over the question by using the chat button.
Standard and tests are very important in to develop the device and new technology to fight COVID-19 as well. Because if you don't have the standard, so the doctor will not attempt to use this device definitely. So in this case, I will show you that there are many items in the standard, but I show you for some items as these linear emissions that can guarantee that our product don't generate, will not generate the noise or radiated signal to interfere to other devices in medical place or in the hospitals. So in this case, we can pass this by using some techniques of the noise reductions. Also in the IEC 60601-1 and -2, there are not only one condition for testing, it's many conditions, many items to pass, about 25 items. Yes. Okay, we have to choose the very good standardization devices to test our device as well. So for example, we use the flow meter about the flow analytics to check the flow, check the oxygens, and also check the temperature of the developed systems or developed equipment. In this case, we measure the flow. You can see in there here about the blue line and the jet orange line here is very close to that. That means our device can produce the flow accurately when compared with calibrated meter here. And also the error is less than 10%, less than 5%. That within the standard of flow of the medical device, they provide us the standard can be called plus minus 10% is enough. So this graph shows the measuring data and measured data, and also measured data from our set point. If we set the flow, on 10 liters per meter, and we put the sensor for adjusting the oxygen to 30. We can check, we can measure close to 30. As well, we set for 60. Okay, the measuring from the analytics, through analytics, or it means the standard calibrated devices is almost the same as our setting. So that's why the error is less than 5% as well in this case. Change the flow to many set points, for example, 60 liters per meter, and checking about the FiO2 is mean the oxygen between our set point and our equipment and our calibrated meters. So you can see the graph is very close between our devices and the calibrated meter, and then the error is less than 5% as well. So not only because we have to put our product to the mass product, our partner is very important. Accredited manufacturing is also the key success in this case to help people in the COVID-19. And we need the company that can gain the ISO 13485, the medical devices. And we have the partner of UQ here to produce our product in the industrial phase and already sent to more than 100 hospitals up to now. More than 80 hospitals and more than 160 patients have already used our product. And so we are proud to say that our product can help the people in Thailand at the COVID-19 situation that make us difficult to work, but also our research team can help the people up to now more than 200 people. So I would like to conclude our case study that the demonstrations of foreseen emerging technology to fight COVID-19 was shown in my slide. And the new technology in IoT and AI applied to the QTL high flow to make the doctor can separate to the patients and can control the remote area. IEC standard tests and the others are the key success to implement, because if you don't have this one, so the FDA and also the doctor will not use or allow you to use this equipment. And more than 80 hospitals and 150 patients have been supported by our KMTL high flow. Thank you very much for your attendance, and I hope that our slide will motivate you, or at least we tell you about the new trend or the room for improvement in the research of the new technology to fight COVID-19. Thank you.
Yes, thank you for your attendance. So, okay, this is my total of my presentation about my topics. Okay.
Well, thank you very much, Professor Samyot Kawitpat Nilai, for addressing this interesting topic. So we have Q&A session. There will be 2 rounds, and each round are for 3 questions. Please raise your hand and mention your name, institution, and also your country. Okay, anybody to ask? Okay, so Professor in this product you already the mass production, right?
Yes.
Yeah. Based on your paper said that the design of housing and also noise suppression is very important issue. Yeah.
Yes.
And carefully design, especially in circuit board, is also crucial for both conducted and radiated emission passing the criteria. How to control the noise suppression in your system, Professor?
Thank you very much for your question. So there are many techniques have to be applied to pass the standard. Actually, when you develop the prototype, sometimes it's very quite fast to get the functional. I like you have get the performance of the flow of the oxygens. It's okay, but for testing the standard, you have many things to thinking about. For example, if you decide that your PC board is not quite good, so they generate the noise. And the noise limit in the level of medical device is really quite strict, more than other equipment. Because for example, for the leakage current, they need the very low leakage, ultra low leakage current. If you decide the device, but sometimes it work well, but it cannot provide a good enough quantity of the safety, so the standard cannot be passed. Many techniques we adopt in this equipment. For example, we use the ferrite coil, or we use the PCB careful design, and also the conducted emission filters. Okay, many techniques which has been applied into this equipment, and then we pass the standard of all of the standards. Another things that we have some trouble in design as well is the layout of the PCB, and also the layout of the heat sink as well. That's making the sums of the stray capacitance, that's making the leakage current. So I can say like that we try to do everything to pass the standard, and then we spend the time, I think, half to half of the all development.
Okay. Yeah.
Thank you.
Yeah. It's very nice. The topic. Okay. In this design, also you have the background, the data, yes, from the doctor before using like clinic
clinical trial.
Yeah. Yes.
Yep. Actually, we would like to talk about this one because we close to the Faculty of Medicines.
Oh, okay.
So in the case, but in the emergency case, we cannot. It's like we don't follow the rule as much as, because at the emergency case, many people require this machine, and they don't ask about the standard at the time, because it's a very emergency, and Thailand has more than 300 people dead each day. Every day we have 300 people die on that situation. So this machine and this equipment is transferred to the hospital in the emergency case and help the people already. And then the standard is like we try to do is later, because in fact I think that some standard is not easy to pass, and then it takes time. But in the emergency case, so many doctors request to use this machine at that time, maybe 2 months ago. So at that case, we have many experience for changing product within 3 months. And it is like we have some team of the researchers that have passion to help people. So that's why we have proud about this product. But okay, when we have time, possible time to do, we try to correct everything to pass the standard, and up to now we already got it right.
Okay, it's actually I am very interested to collaboration with this topic area, Prof. Khalid Van and Lia. Okay. Anybody would like to ask? Yeah, we have 10 minutes for the discussion. Maybe write question in the button chat. Okay. Okay, well, thank you very much again, Associate Professor Dr. Samyot Kawit Pillai, for addressing this interesting topic.
Yep.
Okay. Well, ladies and gentlemen, finally we come to the end of presentation. We would like to say thanks again to Professor Samyot Kawit Pillai for the informative and interesting talk, and to audience for your active participation. We believe this presentation will be beneficial for everybody. And thank you again. Good morning, and we hope we meet again in Thailand, and maybe please you come also to Surakarta, Indonesia. Samyat Karitpat. Okay, thank you very much. Okay, now time is up. I will be give the times to moderator, to master of ceremony, and time is yours.
Thank you, Mr. Ferry Adrian, the PhD, for your smooth and pleasant leading the session. And thank you for Professor Madya Dr. Shatir Asgrar and Professor Dr. Somyat Kaitvanit Pillai for the very insightful speech.
Well, ladies and gentlemen, for the next session, there are two kinds of activities. For the participants who are interested in the plenary session with the speaker Professor Anton Satria Prabuono, kindly please stay on this main room. And meanwhile, all participants are requested to check on their own YouTube channel in order to answer the question from the audience. Thank you. Okay, now I will hand out the session to the moderator in the plenary session with the speaker, Professor Anton Satria Prabuono. Okay, I'm sorry, there is a housekeeping note. So for the plenary session with the speaker, Professor Anton, will be starting at 12 p.m. So for this session, I requested to the participant to check their own YouTube channel to answer the question from the audience. And you are welcome to back again to this main room at 12 p.m. Okay, you may back to this main room at 12 p.m. for a plenary session with Professor Anton, and 1 p.m. For the next keynote speaker session. Thank you.
Ladies and gentlemen, the next session is going to start in 5 minutes. Kindly please be prepared. Well, ladies and gentlemen, we are continuing our meeting agenda, that is plenary session, with the speaker, Professor Anton Satria Prabuwono, PhD, and also I invited Dr. Anwar to moderate this session. Do I have Dr. Anwar here?
Yes, I hear the voice.
Okay, Dr. Anwar, the time is yours.
Okay, thank you very much. Ms. Ramandia Ayu Damayanti. Today, First of all, I would like to welcome to all participants to this plenary session of International Conference on Industrial, Mechanical, Electrical, and Chemical Engineering 2021. I would like to thank to all participants for joining this plenary session. Let me introduce myself. My name is Miftahul Anwar, and I will be your session chair. Here, we have two invited speakers that will present their research in this room. First presentation will be given by Professor Anton Satrio Prabuwono from King Abdulaziz University from 12 o'clock to 12:25. Hello, Prof. Anton.
Yes, I am.
Okay,
How are you?
thank you very much.
Welcome.
How are you today?
Alhamdulillah, fine. How about you?
What time is it now in Saudi?
It's about 8 a.m. in the
8
morning.
a.m.
Yes.
Okay. Oh, nice.
Yes.
Okay. For the first session of presentation, before that, I would like to inform you that the second presentation will be given by Prof. Madya Dr. Syed Ahmad Helmi bin Syed Hassan from University Technology Malaysia from 2:35 p.m. Later in this room, the same room. So for participants, please come again to this room at 2:45 p.m. For this session, first session of presentation, I would like to inform you the CP of Prof. Anton. His name is Anton Satria Prabuwono, professor from Department of Information Technology. He is a lecturer and a researcher, Faculty of Computing and Information Technology in Rabiq King Abdulaziz University. Okay. His education background, he received his bachelor degree from Computer Science University of Pajajaran, Bandung, Indonesia, and from Electrical Engineering to Teknologi Nasional Yogyakarta, and he received also his Master of Science from United Kingdom, Computer System Engineering, University of East London, and his PhD in Industrial Computing, University Kebangsaan Malaysia, Bangi, Malaysia. He is now a professor in King Abdulaziz University from 2016 until now. Is it right, Prof. Anton? Okay, and he's now head of Artificial Intelligence Lab, King Abdulaziz University. He has many publications, supervisor, and community service. For example, he has 5 books, 19 books chapter, and 85 international journal articles, and many international conference paper, around 19 here, 90. And he's also invited as keynote speaker, invited speaker for 50 times. And he has also awards and recognition. For example, world-class university, world-class professor from Ministry of Research Technology and Higher Education, Indonesia in 2019. Okay. To begin this session, I would like to invite Prof. Anton Satrio Prabuwono to present his presentation. The presentation time is 20 minutes, Prof, and 5 minutes for Q&A. For the participant who plan to ask the question after the presentation, please raise your hand or type the question in the chat box inside this Zoom. Okay, Prof. Anton, time is yours.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and very good morning here. Maybe in Indonesia, I think good noon right now.
Afternoon.
Yes, afternoon maybe, yes, correct. Okay, so before I proceed the presentation, I would like to thanks to organizing committee for inviting me to deliver a speech in seven international conference on industrial, mechanical, electrical, and chemical engineering, or ICIMECE 2021. All right, so today, also thank you for the participant for attending this session. All right, so today I'm going to present some research result. Yeah. Right. Okay. Can you see my slide now? Dr.
Yes.
Miftahul, yeah.
Yes,
Thank
it's
you.
clear.
All right.
Okay.
Clear. All right. So the presentation is entitled Vision-Based Natural Produce Classification using Statistical Color Features and Derivative of Radius Function. So my name is Anton Satria Prabono, yeah, and I'm from the Faculty of Computing and Information Technology in Rabic, King Abdulaziz University, Jeddah, Saudi Arabia. Yeah, so we have two campuses. The first one, the main campus is in Jeddah, and the second campus is in Rabic. So actually, I'm in Rabic, around 150 kilometers north of Jeddah. All right, so this is my email address, and this research is actually in collaboration with Joko Siswantoro in Universitas Surabaya, Indonesia, and Azizi Abdullah and Bahari Idrus in Faculty of Information Science and Technology, University Kebangsaan Malaysia, and Joko Siswantoro, I think, in Faculty of Engineering in Department of Informatics. Right. So this is the outline of my presentation today. So the first, as usual, I will start with the introduction and then continue with the related works that the motivation and the background of this study, or this research, and then continue with the material and methods, which cover computer vision system, image acquisition, segmentation, feature extraction, classification, and validation as well. And then I'm going to present the result as well and the conclusion of this research. And also I'm going to show the potential or the possible application of this research. All right, so the introduction, natural produce classification actually aims to classify the produce into one class. So we are going to classify actually some produce, which is a natural produce, and then the application is actually in agriculture industry, like for the purpose of sorting. So if you are going to sort or to select the good product, then we perform the sorting task in this case. And then the grading, for the purpose of the grading. So you are going to select or to choose the good quality of the produce or product. So then we perform the grading task in agriculture industry. And then for the measuring purpose, such as for if you want to measure the volume or the size of the produce. And then the pricing, it relates to the pricing strategy actually, because of it relates to the quality of the produce that we get from the agriculture industry. So these are some application of the potential application, especially in agriculture industry. And then the traditionally this task is performed by the human, so manual task actually. So as we know that if we perform this task, the quality control, for example, or sorting, or maybe grading, even measuring. So it will result inaccurate in the produce classification, because as we know that the human is actually inconsistent and yeah, easy to get bored, yeah, in many situations. Anyway, so then beside that also, it is difficult to standardize, yeah, since the human is subjective, yeah, as we know, that because of the judgment or the justification, each human is actually different. So that's why we cannot, make a standardized for produce classification. And then computer vision is also a promising method, yeah, especially for natural produce classification. These are some related works, yeah, for this research, yeah. Current research in computer vision for natural produce classification, yeah, as mentioned in the reference 12429, yeah. Yeah, such as using combination of very long features descriptor, yeah, as mentioned in 528, yeah, specifically like answers, descriptors, and color coherence factors, and border or interior, global color histogram, appearance descriptors, color autocorrelogram, local activity spectrums, and also edge orientation autocorrelogram. So these are some long features descriptor that, actually to classify the produce, the natural produce. And then also using the complex classification method. So some researchers obtain the classification accuracy, yeah, more than 97% actually, as stated in reference number 5, 6, and 8, like a fusion of SVM, yeah, support vector machine, with RBF kernel and backing ensemble of linear discriminant analysis, and as well as fusion of binary classifier. And then beside the complex classification, also, it needs more time, yeah, for classify or to classify the natural produce. Yeah. So to extract the long features from an image, yeah, whether this is a static image or dynamic image, and then to train the complex classifier using the long features. Yeah. So yeah, it takes time, yeah, more time. All right. So these are the materials and methods. Yeah. So we conduct the research by using the computer vision actually. So we divide into two parts. Yeah, the first part is a hardware part, and the second one is software part. So in hardware, it involves camera, yeah, the normal camera, yeah, with webcam. Yeah, we can use a normal camera. Yeah, so we can buy from the market actually, yeah, from the computer shop and so on. And then the light source. So we install the light source on the top of this one, the light source, yeah, on the top of the the object, yeah, the object, the area of that will be covered by the vision, yeah. And then this is the camera, yeah, and then we connect to the computer, yeah, with the personal computer or laptop. So yeah, preferably with the high spec computer, yeah. I mean, in terms of high performance, yeah. Even though we can use the normal one like Intel Pentium 7 or 5, yeah, with the good RAM, yeah, or memory. And then software, we can use MATLAB, yeah, the application, yeah, to develop the algorithm. All right, so this is the produce, yeah, or product, as you can see. Yeah, this is a produce, and then this is the, the layout, yeah, the layout of the experiment, as you can see here, yeah, in our lab. Yeah, so then we put the camera here, yeah, with two cameras, yeah, in order to get the, stereo vision. Yeah, so then we can see the effect of the 3 dimension of the image. And then in terms of the algorithm, yeah, so we perform by using the image acquisition. Yeah, this is the step in image processing. Yeah, so in order to get a good image, so we have to put the camera from the top, from the top of the object or from top view. And the produce was placed about 40 cm below the camera, the webcam. Yes, around 40. So we can adjust this. It depends on the light as well. The lighting, environment. Especially in order to to minimize the noise resulted by the environment lighting. And then we have to put the black background. So we should do this. I mean, in terms of if we are going to get the clear result, so we have to to subtract actually the background. So that's why to get the easily performance, I mean, in terms of the background subtraction, so then we select the black color for the background, like this one. So like this one, this one also acceptable actually, but then still better than the first and the second one. So then in the image, we save in RGB format, with the size of 640 times 480 pixels, 96 dpi dot per inch, in terms of the resolution. All right, and then the segmentation part, this is one of the step in image processing as well after image acquisition. Segmentation, it is actually to spare the produce from its background, as I mentioned. Then we are going to subtract the background from the image, from the main image. So this is the process from A. This is the original image actually. So A is original image. And then B is image in H channel, and C image in S channel, because of we convert the RGB format to HSV, in order to remap and to get easily for the human to recognize the object. So we convert this image by using the HSV and use only image in S channel. And then we implement the Gaussian filter, in order to remove the noise and enhance the object. And then automatic thresholding and by the morphological openings and closing. So as we can see from this image, so the D is, so H, this is H, B is H, and C is S channel, H channel, and C is image in S channel, and D is image in V channel, and E is a binary image, and we convert into the binary. And after that, we got the segmented image before we proceed to the next step. All right, so then after image segmentation, we go to the next step is feature extraction. So we divide into, as mentioned in the title, we use the statistical color features with 12 features and derivative of radius function with 4 features. So then it covers the mean, standard deviation, and skewness and kurtosis. So then the pixel values is in HSV. So because of we have converted this image, RGB image, into HSV channel image. So then for derivative of radius function also cover the means, standard deviation, skewness, and kurtosis. So with 36 values of radius function is measured for theta more than 0 and less than 2 pi, with the interval of delta theta equal to pi divided by over 36. So this is how to calculate the radius function. All right, so then the classification part. So after the feature extraction, the first one is image acquisition, segmentation, feature extraction, and then the last one is classification. We use a k-nearest neighbor and artificial neural network. So we compare both methods, method of classification. So in k-nearest neighbors, or KNN, K was determined by the experiment, so it is a try and error. Yeah, so we tried one by one the K, and then we use a Euclidean distance to measure the closeness between testing and training sample. Yeah, in this case. So this is the KNN. Yeah, so we find the nearest neighbor. Yeah, for each data. Yeah, in terms of the classification, and then the second one. I mean the KNN we compare with the ANN, artificial neural networks. Yeah. So we developed the 3 layers of ANN, yeah, with the input of 16 neurons, and the hidden layer, yeah, the number of neurons determined by the experiment. So we perform some experiments to determine to get the number of the hidden layer. Yeah, and then the output. Yeah, the output is 3 neurons. Yeah, and then we use the transfer function of Tensig, and we implement the learning algorithm by the Levenberg-Marquardt backpropagation, yeah, in artificial neural network. So these are the architecture of the artificial neural network. And then for the validation purpose, after we develop the algorithm, yeah, the architecture of the ANN, as well as the method of the KNN, yeah, so we validate both methods, yeah, by using some data. Yeah, so the data set. So for the preliminary experiment, we use 160 images, yeah, of natural produce, yeah, which consists of 53 apples and 52 mangoes and 55 tomatoes. So because we select the good image, actually, we tried many times, yeah, to capture the image, yeah, from the original object, yeah, the original apple, mangoes, and tomatoes. But then we selected this image, you know, so images. So we got only 160. And then 50% samples were randomly chosen as the training set, and the rest for the testing set. So that we select 10 training sets and 10 testing sets, yeah, and we conduct the experiment. And the classification accuracy, so we use the normal calculation or computation. So the number of samples correctly classified divided by the total number of samples and times 100%. So the result. So we got the two results, of course. Yeah, the first one from the KNN classifier. So the KNN classifier, yeah. So the number of the nearest neighbors, yeah, K was heuristically determined for K more than 1 and K equal less than equal 10. And then the best average classification accuracy, actually using K equal to 1 and K equal to 2. Yeah. So even though we determine with K more than equal 1, less than equal 10, but then we got K1 and K2 as the best average classification, yeah, in this validation process. So we got the training, yeah, the performance, 94.25%, yeah, for the training, and then for the testing 74.5%. Yeah, so this is the performance of the accuracy performance for K nearest neighbors. Yeah, so the first one, yeah, this is the testing. The red line is the testing, and then this one is the training. Yeah, this is the testing. All right, so this is the KNN classifier performance, and then the second one is NN classifier performance. Yeah, so the number of neurons in hidden layer heuristically determined, yeah, from 2 until 12 neurons. Yeah, so we determine from 2 until 12 neurons, and the best average classification, yeah, for the accuracy, accuracy performance, achieved using 9 neurons in a hidden layer. So actually we perform the experiment by determine the hidden layer from 2 to 12 neurons, and then we got the best classification accuracy when we use 9 neurons in hidden layers. And then the training, we got the training 100%, and then the testing 99.875%. So this is the figure, the graphical of the training and testing for an classifier. 100% and 99%. 99.875. All right, and then the average processing time. So not only the performance, the accuracy performance, but we also measure the average processing time for both method, CAN and ANN. So process of raw sample image and extract features, for the first one, the extra feature extraction, less than 0.22 second. This is the raw from the raw sample image, and also for the feature extraction. And then the classify testing set, using CAN, for the classification, classification testing. So less than 0.01 second per sample, and training for ANN less than 1 second. And then classification testing set using ANN also the same, less than 0.01 second per sample, and the total time used to classify the new produced image less than 0.23 second. So these are in terms of the average processing time, because so it is very important when we develop the computer vision based, especially quality control. In this case, we implement to the produce natural produce classification. All right, so the conclusion. So the research proposed natural produce classification using computer vision based by implementing 2 methods, the simple statistical color and derivative of radius function. And then we compare the performance of the classification by using the CAN and ANN. So the preliminary experiment performed using 160 samples, with 53 apples, 52 mangoes, and 55 tomatoes. So we use the real object actually, real natural produce. And then the total time needed, to classify produce image was less than 0 for both methods, less than 0.23, for CAN and ANN. And then the classification accuracies, this is the important one, the performance of the classification accuracy, where 74.5% for CAN and 99.875% for ANN. So in this case, and we can conclude that ANN is better than CAN in terms of the classification accuracy for the natural produce classification. All right, so this is the video of the example of the application. So actually we can apply this algorithm to classify the natural produce. For example, in industry, as a quality control actually. So as I mentioned, for sorting, grading, measuring, as well as to see the quality of the product, even for the quality control purpose. Right, so this is the example. So we can also implement for the robot, the picker robot. So then when the robot want to pick the object, the produce natural produce, in terms of the plantation, in the plantation. So then we can implement this algorithm as well. So the robot can recognize which one the apple, the mangoes or tomatoes. So then we can also put the threshold, for example, only the big size of the natural produce that will be picked by the robot. We can estimate by using this algorithm. All right, so we can see this one. So it will recognize each natural produce. This is orange, for example. So then we can implement this algorithm to recognize this object. All right. So the reference acknowledgement. So this research is funded by ERGS, in UKM, and also internal grant of KU, King Abdulaziz University. All right, so that's all my presentation today. So thank you very much and terima kasih. So time I return back to the moderator, Dr. Miftahul. Thank you very much.
Thank you very much, Prof. Anton, for a nice presentation and about the computer vision. This is actually some kind of image processing, yes, Prof. Anton, or?
Yes, correct.
Yes, okay. Maybe this is higher than image processing. Okay, then we go to the discussion session. Yeah. Are there any questions or comments about this presentation from the participant? Dr. Pringo, maybe? Okay. Please.
Okay, thank you very much. Thank you very much, Professor Anton, for your interesting and insightful presentation. I would like to ask about the feature extraction. How you decided to make how the feature extraction you use, and how about the second question is about the index performance. You use accuracy. What do you think about another index performance, like such as precision and also recall, or another performance? It's maybe for considering another performance, maybe will be better for your analysis. Thank you.
All right. So I answer directly?
Yes, please.
Okay, so thank you. Thank you for the good question from participant, Dr. Pringo. All right, so actually the the feature extraction, we selected the method using the combination of the statistical color features and derivative of radius function with 12 features and also 4 features. Yes. So then actually based on the study of the literature, after we compare some method, and then we show that this feature extraction more faster, that one based on the literature study. Then we try the experiment, because we didn't perform the comparison directly by our side. So we just study the selection of the feature extraction based on the literature review. And then we compare the classification part also, that one, the feature extraction, using the statistical color and derivative function, radius function, and then we compare the classification, because of the classification also the important step in image processing.
Yes.
So that are the that is the last of the process, in image processing, the classification. So we compare KNN and ANN. So in terms of the
I'm sorry.
performance,
How many target classification?
Yeah, we perform. We actually we have a 160 data set. So then we classify the object based on the size. Yeah, because we classify the mangoes, the tomatoes, and also the apples.
Oh, so
three objects.
Three object.
Three objects.
Three object.
Yeah.
Three object and only three, not four.
Only three. Yeah. So far only
Oh.
three. Yeah. Because this
Okay.
is the initial experiment, and as well as
Yes.
performance. Yeah, the performance we measure only the accuracy performance and the processing time. Yes, as you mentioned that we can add some additional performance measure, like maybe in terms of the recall, for example, and then maybe the precision. Precision actually close to the accuracy.
Yes.
But that one is good input. Later on, then we can combine those performances into the current performance. Thank you very much. That's my answer.
Okay, thank you very much, Professor Anton. Thank you, sir.
Thank you, Dr. Ringo, for your question. And next question will be from Mr. Zulfikar. Mr. Zulfikar, you can open the mic now.
Okay, thank you for the time. Allow me to introduce myself. My name is Zulfikar Condonasta. I'm from electrical engineering in 11 Maret University. Maybe my question is out of topic, but here is my question. It is predicted that robot will replace many human jobs, especially people from the lower middle class whose jobs are usually monotone. My question is, then where will the people who have lost their jobs go, because all the work they could have done has been done by robots? Thank you.
All right. So can I answer?
Yes, please.
Right. Yeah. So thank you for the interesting question. Yeah. So because it is happening for the countries with the huge population, like Indonesia. When we talk about robotic and automation, then the people will argue. So where the existing people will go? Yeah. I mean, because if we replace the human directly by the robots, then the problem of the shortage of the the opportunity of the job opportunities will gone, because of replacing by the human. All right. So actually we have to consider when we are going to implement the automation in terms of the robotic in this case. So then for the job, actually for the dangerous job, and for the boring job, in terms of if the job need the consistency, for example, if we are going to repair, like in the nuclear reactor, for example, or in the area that just that the disaster happening in some areas. So then we can send the robot to perform the rescue, something like that, or to repair the leakage of the like power generation, power plant generation, maybe nuclear power generation, or maybe gas, and so on, the dangerous area. So then we can use the robot to replace the human. So for the task that humans still perform, the task, I mean, manageable, the task manageable by the human, so then we can maintain the human resources. So, but then for the, especially for in the case of Indonesia, in other countries, of course, this is not a big deal because of the job like this is actually, even no people want to take this kind of job. because just to pick the fruit, for example, to pick the vegetables, to load the fruit and to move one container to the other container. So this kind of job actually in other countries, yeah, no people will take this kind of job. But in Indonesia, maybe, yeah, even this job, yeah, many people want to do this work. Yeah, so that's why. So then we have to be careful when we want to determine to replace the human with the robot or the automation. Right. That is my answer. Thank you.
Okay, thank you, Prof.
Okay, thank you very much for the question. I have one question, Prof. Anton. I've ever seen some video from YouTube, for example, in China, they have also the system, some kind of this system to subject some people in the road, for example. Is it the same system for example, with your system?
Yeah. This is similar. We using the similar method, yeah, to recognize the people, yeah, to detect or to recognize the registration vehicle registration number. Yeah, it is using the same method, because of this kind is actually a part of the object recognition.
Okay. So it is also possible to recognize the smaller object, yes, or not? For example, nanomaterial or some kind of like that.
But for micro or nano, I think we cannot use the normal camera. We have to convert the image using the maybe digital camera or maybe the specific sensor, yeah, to detect the object. Because of the most important thing in the image processing, also we have to consider about the sensor. In this case, we use the normal camera, webcam. But for nano object or micro, then we have to use the special purpose of the sensor.
Okay.
Jadi good question.
Nice information for me, for all the participants, Prof. Thank you very much. And any other question from the participants before we end this session? No? I think not. Okay. Thank you very much, Prof. Anton Satrio Prabuwono, for the nice presentation. Many information about the image processing and computer vision here. And I would like to finish this session. Again, thank you very much, Prof. Anton, for presenting your research here. And for the participant, again, I ask you to join again in this room from 2:45 p.m. Yes, for the next presenter, Prof. Madya Dr. Syed Ahmad Helmi bin Syed Hasan. Thank you very much. I close this session. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you very much.
Time is yours, Miss Ramanda. Oh, Miss Samira.
Okay, thank you, Dr. Anwar and Professor Anton. Well, ladies and gentlemen, we are now continuing our meeting agenda, that is to hear the keynote speech, which will be moderated by Dr. Engineering Pringgo Widyo Laksono. But before we hand out the session, please allow me to give you a brief introduction of our moderator background. Dr. Engineering Pringgo Widyo Laksono is an associate professor in industrial engineering. Since 2005, he joined as researcher at Production System Laboratory, Faculty of Engineering, Universitas 11 Maret, Indonesia. He was received degree Doctor of Engineering from Gifu University, Japan in 2021. His research interests are automation and production development system engineering, human-machine interaction, intelligent machine, human factors engineering, robotics, and control system engineering. Currently, Dr. Engineering Pringgo Widyo Laksono is conducting research in monitoring, evaluating, and controlling production system based on intelligent system and biosignal. Ladies and gentlemen, without any further ado, please welcome Dr. Engineering Pringgo Widyo Laksono.
Assalamualaikum warahmatullahi wabarakatuh. Thank you very much, Miss Samira Bianti. Good morning, good afternoon, or good evening, ladies and gentlemen, depending on where you are. The Honorable Dean of Faculty Engineering, Universitas 11 Maret, the Honorable Chair of the 7 Icimece 2021, the distinguished speakers and all participants, welcome to the International Conference on Industrial, Mechanical, Electrical, and Chemical Engineering 2021. First, let me introduce my name. My name is Pringgo Widyo Laksono. I come from Universitas 11 Maret. I'll be responsible for hosting this session in the fifth keynote speaker. I would like to extend my warm regard for all of you in this prestigious event. I'm glad to welcome Professor Dr. Engineering Hendro Wicaksono, who will present the role of artificial intelligence in accelerating the transition to green electricity. Professor Hendro, are you ready? Oh, are you, Prof. Hendro? Can you hear me?
Yes.
I see. Are you okay, Prof. Hendro? I think now it's in the morning in Germany, maybe.
Yes, it's
What
still
time?
like 7:45.
Oh, 7:45. Actually, I'm in Japan. Now it's 8:15. So in Indonesia, 15. Okay. Before Professor Hendro deliver his presentation, I would like to introduce our distinguished speaker today, Professor Dr. Engineer Hendro Wicaksono, Sarjana Teknik Master Science, come from Sidoarjo, East Java, Indonesia, but he got doctoral engineer in mechanical engineering, Karlsruher Institute for Technology, Germany, in 2016. And now he is a professor of industrial engineering and also head of research group in the intelligent INDEED, or Intelligent Data Management in Industry 4.0 in Jakob University, Bremen. And he got many achievements, especially he already published more than 50 scientific publications in the reputable journal, and also he already invited more than 100 talk, something like as a speaker or keynote speaker. And the last one, maybe his achievement is Teacher of the Year at Jakob University Bremen in 2020. In the next talk, he will introduce about interdisciplinary applied research project that cover multiple topics addressed in Icimece 2021. That is renewable energy, industry 4.0, artificial intelligence, big data, machine learning, IoT technology, and new normal services. And it focuses in the role of artificial intelligence in accelerating the transition to green electricity especially in Europe, because Prof. Hendro many doing many research in Europe, especially in German, and it discussed the challenge within the transition. Transition, maybe it's related with energy transition index or something. What is challenge within the transition toward the green electricity, and how digitalized through smart metering addresses the challenges. It's been like maybe like smart IoT in the measurement electricity, something like that. And I think now please welcome our distinguished speaker, Professor Dr. Engineer Hendro Wicaksono. Time is yours. Maybe 30 minutes for presentation and 25 minutes for question and answer. Please welcome.
Okay, thank you very much, Professor Pringo, for introducing me today. So thank you for the leadership of UNS and also the organizing committee for the opportunity to invite me to this talk. So today I will like to share some of our research projects that in the framework of using IT and AI to help the transition to green electricity. So I would like to share my screen right now.
Okay.
Can you see my screen?
Okay, clearly. Okay.
Yeah. So before I start with the talk, I just want to introduce our research spectrum in general and our university. So Jacobs University is located in Germany, so in the northern part of Germany, northwest here, you can see. So it's in the state of Bremen. So it's a small state along with Hamburg and Bremen, and Berlin is kind of city state. So the other hand, you have bigger states who has some capital. And Jacobs University is an international university who is quite small and young with 1,500 students and founded just in 2001. But our focus is more in research. So what is also the unique is that we have students from around more than 110 nationalities, yeah, including Indonesia, and also bigger countries like US, China, Japan, to the small countries like Maldives, Mauritius, and so on. So it's quite international. So it's also reflected in, sorry. But there's a problem with, it's also reflected in my small group, so-called INDID, Intelligent Data Management Industry 4.0. You can see here that within small group, we have around 6 PhD students internal from different countries, and also 3 external PhD students funded by industry and cooperation with some research institutes. And we have also around 20 master students and bachelor students as teaching assistants and research assistants. And our research focuses on the integrations, the whole life cycle of data actually is the holistic data management, from data integration through an approach called linked data, and also data analytics, and also how we can represent the results of data analytics and machine learning in form of formalized representation in knowledge graph. And we also connect to human-centered technology like AR, VR, especially in the semantic enrichment of the objects, that it's then visualized and interacted in AR, VR. And because we are actually still in the cluster of industrial engineering, so the innovation technology and technology management, which focus on the transferring the research results into innovations and also commercialization, is also our focus. And our application fields more in smart cities, supply chain, construction, and healthcare. And today's presentation will focus on smart cities, actually, and supply chain, which is also which focus on the manufacturing. So we have also some cooperation with Indonesian institutions as in terms of research collaborations, visiting professorships, young professorships, and so on, and also with the industry from different fields. For example, our students now working with football club Werder Bremen to analyze the fitness of the athlete and recommend some kind of the best training for each athlete based on the health data. So it's kind of using machine learning to recommend the best trainings and the best time for trainings and so on for specific players. And we have also some cooperation with the university from outside Germany, like in Ireland and UK. Okay. So now I would start with the sharing of the main topic of our talk today. So I'm also quite active in building startup. For example, we have a startup right now that focus on the sustainability, so-called Green Indonesia. We want to kind of disseminate the green technologies and try to involve different actors to contribute to the environment, not only companies but also like citizens. So the context of the talk, as Professor Pringle mentioned before, so our problem domain in our research in this talk is the renewable energy, how to adopt renewable energy, and what kind of methods and tools we use in our research that we discussed today is IoT to collect the data, big data, and the AI and machine learning to analyze the data. And then the impact is to provide some kind of new service, new data-driven service to the manufacturing companies. So it's kind of one of the pillar in Industry 4.0, which is so-called data-driven service, along with smart product, smart process, and smart infrastructure. So today talks will be divided into 5 parts. I will start with what are the challenges and in the transition to a green electricity, especially in Germany and Europe, so that motivate our research, and the role of digitalization in energy transition. So this is kind of like the prerequisites of our research to have some kind of digitalizations. And then the concept behind our research is called demand response and dynamic price. And then like the solutions which based on AI, and the scaling up to the broader context, which is in the context of smart cities, the whole cities, not just some parts or some specific consumers. So what are the challenges in the transition to green energy in Germany? So because of the Fukushima disaster, so the German government decide to shut down all of the nuclear power plants by 2022. So they already started it and almost finished. And as the consequence, they need to use more green energy, especially from wind energy. So the aim is then that related to that is to have less greenhouse gas emissions, and also to have more than 45% renewable energy in the electricity consumptions, and not only transiting to the renewable energy, but also that the consumption should be reduced. So there are different programs to support this. And what about the achievement of the use of renewable energy? So it's quite good actually. And so it's quite, right now Germany has around 57% of green electricity. So you can see here, mostly from the wind power. And followed by biomass, hydro, and I think this followed by here solar, here 12%, and biomass and hydro. Germany has faced also the aging of hydropower systems, so they want also to shut down some of hydropower facilities because of the age, not efficient enough. So they want to move to mostly to wind, solar, and biomass. So how Germany accelerate the adoption of renewable energy? So if you can see here the tariff of kilowatt hours in cent, and the components of this tariff related to the cost, you can see here there's significant proportion of the tariff that goes to subsidies for the development of renewable energy facilities. Yeah, only around 25% network cost and 25% around 25% generation cost, and the rest is actually it's kind of fees and also subsidies. So you can see here quite a significant proportion to support the introductions of renewable energy sources. More than 50% is for taxes, fees, and subsidies or contributions. But the adoption of the green electricity is still a big challenge because of the geographical conditions of Germany. So first, like wind energy, solar, and so on, is the availability depends strongly on the weather. So that means we need to have a solutions to optimize the use of this uncertainty of the availability. And the storage to store the electricity is still expensive. I mean, so if there's a lot of energy available because of the good weather, so it's difficult to store it in the storage because the storage is still expensive. And the distribution is not really well. So like the source of the energy mostly in the northern Germany, but like the consumptions, like the manufacturing's mostly concentrated in the southern Germany, like this. And the solutions along with smart storage is to have some kind of support of IT or ICT in so-called smart grid, where the consumptions, mostly consumptions, should be regulated based on the availability of the generations. And this should be then integrated into kind of smart buildings and also smart home with the capability to control appliances and devices. And now we know the challenges and so on, and how we could enable to do this, to make the infrastructure smart. Yeah. So it's used so-called digitalizations. So what are the digitalization dimensions that is possible in the transition to green electricities. So we can use some methods here like IoT, AI, and big data that we focus on our projects actually, and along with digital twins for the simulations, for example, and blockchains for the trading, energy trading. And the applications from simple data analysis also to regulations and operations of the grids and automations of the processes. And the infrastructures, IT infrastructure can be local, centralized, or mixed. So we use mixed infrastructure that combining edge and cloud computing. And the application fields is the whole supply chains of energy from generation, network and consumptions, and also the manufacturings of the components used for transitions. So the core technologies to enable the transition is so-called smart meters. The smart meter here, so you can see it. Yeah, the smart meter is here is not is a requirement not only for the smart grid, yeah, but also for the smart mobility. So for the electrical vehicles and smart home and smart service like assisted living, which we usually use in elderly homes, in senior homes. So that means this so-called smart meter gateway provide some kind of standardized communications between devices involved in these different fields. From the grid itself, in the charging stations, for example, house and also buildings, and also other services then that are built on top of these different smart services. So the smart meters usually look like this. So it's kind of a device which is connected. This is like so-called smart metering infrastructure that consists of also smart meter gateway like this. And it's kind of connected the local metering network, connecting different network from the electricity metering, gas metering, and so on. And also it connects to the appliance and also infrastructures. There is also now so-called home charging stations that's still developed, is being developed now, and also connect to storage and energy generation and consumptions appliances. And it's then connected to other parties, like, for example, the utility companies, some industry that provide the service, like optimization service, data-driven service, and so on. So it's connected to cloud. And for the transition towards green electricity, the participation of the consumers is very important. And how consumers can be actively participate in this transition. So now to engage the consumers in the transition, so the concept of demand response and dynamic price is being introduced. And what is demand response or demand system management or demand management systems? Let's imagine, so the availability of renewable energy is in the yellow curve like this. So it's kind of, for example, it's from the solar. So, and the peak is at the noon. The availability, peak availability is in the noon. But the consumption mostly, the peak is around 7 p.m. like this here, 7 to 8 p.m. And demand response here is how to change the behavior of the consumer so that they can move their consumption to the time where the availability of the renewable energy is quite high, like this. Right, so to shift the red area here to the green area. So this is kind of how to still people use 100% renewable energy. Otherwise, the utility company needs to provide some energy mix here to add some generation from the coal, for example. So according to some studies that it can provide of flexibility around 160 gigawatts in 2030 and can reduce energy supply costs, mostly load cost, in billions euros. Yeah, it will save the cost. So, and by introduction of the demand response, it's kind of changed or transformed the relationship between generator or the utility companies and the consumption. So as the status quo right now, so the amount of electricity generated by the utility companies of the generation like PLN in Indonesia depends on kind of analysis on the consumption. Yeah, like how much the consumption per year, for example, or what is the peak, how much is the consumption in the peak time, and so on. And then the utility companies built the infrastructure accordingly, according to the load required by the consumer. But now the transformations using the demand response is we have the availability that quite depends on the weather. So and now how we can manage the consumption based on the availability in the generation. So that means that the generation now control or manage the consumption. The consumption needs to change according to the availability of the renewable energy. So one of the way to implement that is to introduce so-called dynamic electricity price. So that means the price is variable. So it will change, it's planned every 15 minutes, change the price depending on the availability of the renewable energy. This illustration say that if there's a lot of wind, a lot of availability electricity, and the electricity should be cheaper. But if it's a few wind, less wind, and less electricity and expensive than the electricity. So that means the electricity will change every 15 minutes depending on the availability of the renewable energy. So that the people then want to change their behavior to shift their activities to the time where the electricity is cheap, or that means when a lot of available renewable energy. So there are some countries that have already implemented the dynamic pricing. So the most advanced countries are the Scandinavian countries, Estonia and the UK. So they have already built the infrastructure for the real-time pricing. Real-time pricing is the price will update it in real time depending on the availability of the renewable energy and also based on the current demand. So it's some implemented every hour, some implement 15 minutes. Like in Germany, want to follow the 15 minutes time. And there's also not other countries like Japan and France here, which also introduced some level of dynamic tariff dynamic price, but not as advanced as these 5 countries. So according to some studies here, even for the industry, especially for manufacturing, the introduction of demand response will give some kind of lot of savings. Here you can see big saving, perhaps not the energy saving, but more like the load saving. So it's also will save the cost for the generations. And now how to implement the demand response and what are the roles of the digitalizations and AI here. So this we implement in a project so-called Delphine. This is a kind of big project that funded by the German Ministry of Economics and Technologies. So we collaborate with some research institutes and small medium enterprises like Kottenburger and Matek. They are manufacturing companies as the consumers, and SWT here, Stadtwerke Trier, as the provider of utility company. And we have also some IT companies that provide smart meter and also provide some kind of solutions for the cloud solutions. So how AI models are applied in this demand response? So when we could define here generations and the consumption here is focusing on the manufacturing. So not household, but manufacturing companies. So basically we developed machine learning model for the forecast of the generations and the forecasts for the consumption. And then these forecasts are used to calculate the dynamic tariff for each 15 minutes in the future. So usually in 1 day to 3 days ahead. So this different price in the next 3 days, for example, is then transferred to the calculations done by the utility company, and then this price in the next days are transmitted to the consumption through the smart meter. So the manufacturing company can see what would be the price of the electricity in the next 3 days. So they can plan their production plan. They can optimize the production plan by, for example, by shifting the processes to the time where the price is quite low. Yeah. So here we use also still in development, we use hyper-heuristics production optimizations with combining with bio-inspired optimizations. We don't use meta-heuristics because of the reason that there is also some heuristics that we need to consider in production planning. So by using meta-heuristics, it's kind of too random. We cannot introduce some strategies there, like earliest due date or shortest time, process time, and so on. So we can here with hyper-heuristic, we can combine. We still can integrate some strategies, but we search for the best strategies using, or the best combination of the strategies using bio-inspired algo optimizations, for example, using ant colony optimizations. And then after they do some optimization in the next 3 days, the information will be sent back to the utility company to update the tariff. So because the tariff also depends on the consumption side, yes. So it's kind of closed loop between consumption and generation sides. And we have done some experiments of forecast models using different models in deep learning or neural network. So here we use deep neural network, the standard with some layers, and we use recurrent neural network RNN, long short-term STM here. So this is some results you can see here. It's quite, the red is the predicted and the blue is the actual values. There is some, it cannot predict so well for the peak here for STM. And then we also tried convolutional CNN and hybrid architecture that combine CNN, STM, and TNN, deep neural network. And there is here's some of the results that for short-term forecast, for example, for the 1 day to 3 days for wind, and this is for long-term forecast for 1 month. So for the wind, which is the pattern is quite irregular, it's quite chaotic. So the hybrid method is hybrid architecture is the best. But for solar, which has a quite certain pattern, so the deep neural network is the best. So we also now developing Bayesian CAM or general additive model. This is model that developed by Prophet. So then it's based on the statistical modeling, where we can include different parts here in our model, like the trends of the, for example, the generation or consumption. And we can introduce some season. Season can be, because like the consumption is usually follows a seasonal pattern, like in the day, a lot of consumption in production, for example, and at the night quite low. And it's repeating, following some kind of seasonal pattern. And we can introduce holiday, for example, for the consumption, where there's no work there in the factory. But this holiday or disruption can also, we can also, for example, model the storm. If there is a storm disruption in the weather, we can also introduce in the model. And we can introduce additional regressor, for example, not just based on the time series, but also like another time series that represent the weather, the sunlight intensities, wind speed, and so on. So this is for the demand response and how we can utilize data. So in general, to enable energy transition in a larger scope. So we also here had a project some years ago that developed smart energy platform for smart cities that have been validated in 3 cities in Europe, UK, Spain, and Italy. And this project called the READ. So what we developed is so-called smart energy platform. A platform is kind of IT platform to share the data, share different data between citizen, the government, and also industry, especially the energy provider or utility companies. So the aim is the same, to how to reduce the consumption of energy in the city and to introduce the renewable sources as much as possible. So this platform can enable data sharing. For example, the citizen can share their consumption data, and this consumption data can then used by the policymaker to plan, okay, we need additional wind turbine near the city, for example, and also used by the provider to see how demand in order to develop some dynamic tariff, dynamic price. And we have also like a portal like Google, Microsoft, and so on when we have a single sign-on. And we have different apps for different actors here. And this data sharing and different apps reflect kind of integrations of process. For example, data generated by the citizen can be used by government for planning and by the industry for optimizing the service, for example. And we use different data sources from the building level, like the buildings. By using Energy Plus simulation, we can predict the energy consumption of a building based on the infrastructures or 3D drawing.
I'm sorry,
and
Professor.
We can, yes.
Maybe your time almost finished. Maybe
yes,
2 minutes. Okay.
Yeah, and we use here so-called knowledge graph like Google that we kind of uplift the semantics of the data so that it can easily accessed by different applications here. And the applications that we have from the monitoring, just information and awareness to compare the consumption of a citizen to similar citizens, for example, just also informations. And also we can, there is also applications for planning, like simulations with some forecasting there. And simulation when we introduce renewable energy sources, what would be the cost, what would be the improvement in terms of energy supply, and simulation to calculate the tariff and also action. So action here, if there is some improvement, for example, action and to change the materials of buildings or to buy some smart meters during infrastructures and so on, there is also marketplace that's specialized for energy related products. So actually that was my last slides. So sorry, a little bit too long. So thank you for your attentions. So if you have questions, I'm happy to answer. Thank you.
Thank you very much, Professor Hendro, for very bright, clear presentation. And I hope all the participants enjoy the amazing and insightful presentation. Now we come to the Q&A, question and answer. Please feel free to ask question to the speakers, and also you can type the question in the chat box. I think not yet, no question. Very interesting, Professor Professor Hendro, about the, I think I ever read about energy transition index, something like that, and it's mean like your presentation talk about more about the transition to green electricity. And
yeah,
yes.
Pak Ringo.
Yes. Oh,
okay. I have a
okay,
question,
good.
Pak Ringo.
Okay. Thank you. This is my team. Dr. Solihin will ask question maybe. Okay.
Please, Prof.
Okay. Doctor.
Okay. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Thank you, Prof. Hendro. Just wonderful presentations. I'm very far from the electricity or issue about the what they call the modeling, yeah, because my background is a civil engineer, yeah. But for me, what you have presented for us is very interesting. I have some question for you. The first, this is actually the what do you call it? The questions from ordinary people. Yeah, I'm not an expert on it. The first, it's about the in your slide. I saw that the German trend in applying the renewable energy. You mentioned that hydro is not efficient, and then Germany will leave the hydro energy. Yeah. The reason is this energy is not efficient. Yeah. Could you explain more about that? Because in Indonesia, as long as we know that we only apply this potential only about 10% from our potential. We are a very big country, a large country. We have a lot of rivers and bigger rivers and long rivers also. I think so. We have a big potential for this. But you mentioned about this energy is not efficient. That's why the Germany will probably reduce the using of hydro energy as a renewable energy. This is my first question. The second about the terminology of they call the dynamic electricity price. Yeah, yeah. I'm ordinary people. I don't understand about the electrical engineering. Yeah. For my opinions, this is the price will change every time. Yeah. So in Indonesia, there are two issues that will be very what they call very prone for the political issue. The first is the price for electricity, and the second is the price for the fuel. Yeah. What do you think about this what they call this idea? If I saw your presentation, most of the what they call developed country already use this one, but we are different from them. Yeah. You say that if you know if the electricity price or fuel price change, it can be very prone as a potential to be shifted to be a political issue. Yeah, in Indonesia. Can you apply this dynamic electricity price? Yeah. In Indonesia. This is the second. The third about this is probably I don't know. Hopefully, so you can answer this question. We have a look your presentation about the transition process. It needs modeling. It needs simulation. It needs data management. Yeah. Do you think it is good for Indonesia just use a PLN is the only company who run or manage the electricity in Indonesia, or let's say only two big companies such as this PLN and Pertamina who organize or would who manage the energy distribution in Indonesia? What do you think about that? Or probably is it possible? It is better if the government asks many companies to involve in this business. So that's we do hope that the company will compete each other. Then they can what they call give the smaller price for the people. I do hope that you can catch my three questions in this for me. Yeah, thank you very much, Prof. Hendro. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, maybe Prof. Hendro, can you answer directly?
Yes.
Three questions, I think.
Thank you, Prof. Asad. This was a very relevant questions, especially for the country, for our country, Indonesia. So for the first question about what does the hydro power not efficient enough in Germany, for example? This is perhaps first because of the geographical condition of Germany, which is not so many river that is used for like most of the river used for transportations. Yeah. But it's quite difficult, or it's quite costly to take some part of the river and to build some kind of dam or something to do some to have some hydro. So it's quite costly, and there are some hydropower facilities around along the river of River Rhine. So, but those have been built, I think, 100 years ago. So, and now it's aging. So, for the maintenance is quite difficult. So, of the these aging infrastructures. So, therefore, after analyzing different other possibilities, they also analyze the usage of so-called what do you call it? So earth geothermal energy. They also have performed some studies, and it's come up that the wind is the cheapest one, and then followed by solar and biomass. Yeah, because this kind of they need to adopt the renewable source fast to fulfill the target, and the cheapest way is to install many wind power energy in the north of Germany. So it's kind of first the geographical reason, and the second is the cost reason, which is there is a more reasonable alternative. Yeah. And the second the question was about the dynamic price, right? And how it could be implemented in Indonesia. It's a very good questions, and it's quite difficult to answer because it's about the questions about whether is it possible to not to do monopoly, right? Or was the third question? The second question.
The third question, okay.
And the second was.
The second is about this dynamic electricity price. As you know, it's sometimes for us, if the electricity price in Indonesia change, this will be shifted to be a political issue, and this is not easy, to be implemented. Probably for the developed country like what they call the Finland, Scandinavia, it's okay, but for us, it's not easy. I don't know. This is my opinion, personal opinion, but
yes, if it's because I think in Indonesia it's quite sensitive issue because it's kind of the base of the economy, the price of electricity and the price of oil. But what we have, or in Germany has happened, is that there is a political will first from the different political parties. So, and everybody kind of agree that because of the bad experience in the 80s when the Chernobyl the disaster, Chernobyl disaster, and a lot of people, the radiation is also increased in Germany, and the people born around 1987, a lot of them got sick and so on, and I think this kind of collective understanding on why it is good for the people, why it's good for the whole countries, for the futures and so on, is important. So that means this requires some kind of, I don't know, it's kind of communications because between the government, the science, and the people. Like if, for example, the government introduce some policy like this electricity market, dynamic price. So it has a kind of scientific base on it. It has a proof that this is important and has a strong background and so on. And the people and the government communicate this clearly to the people. So there's also some kind of special website for energy transitions, so-called in German Energiewende, so that the information about the reason behind it and so on quite clear for different citizens, different kind of people, like from the industry, what does it mean, from the citizen, what does it mean, and so on. So I think in general, I think what Indonesia should improve is to have a science-based decision making and policy, and have a clear communication infrastructure that can make people from different types, from different level of social level, understand what's the reason behind a policy. For example, in this case, price and so on. Of course, I think most of the people, it costs kind of, I mean, the change of electrical price and change of oil price will cause some kind of political issues, because most of the people don't understand what the reason behind that, and it's then used by some politicians also to like attack or to support some kind of issues. So at least science and transparency is important to introduce new technologies or new approach for the people. And about the third questions about the involvement of other companies, not only monopoly for providing energies, I think it could happen. It could be possible, for example, PLN focus on the infrastructures, like the transmissions, and mostly the transmissions and the distributions. But the other companies could focus on like the customer relations, this endpoint of providing electricity, for example, and also in the generation. The generations, the companies can sell their electricity to PLN, for example, or something like that. So I think that could be an option. I think it's in Germany is similar to that. So that means there is 5 big players that kind of manage the transmission infrastructures, like EnBW, RWE, Vattenfall, and so I think around 5. Each of them has regions, like EnBW focus on the southwest of Germany, and RWE in northwest, and so on. And then each of city has kind of companies, some of them owned by the city government, like Stadtwerke is kind of company owned by the city government that provide a kind of service and manage the customers. And also the companies that manage the generations. But the thing is that mostly because of the source of renewable energy is free, it's from the nature. You don't need to buy some coals, or you don't need to buy oils and so on. It's just from the wind. So it's quite, the cost is quite low for the generation. So it's just investment cost. And then when the wind turbines there, or the solar panel infrastructure is also there. So what you need is just for the maintenance cost, which is perhaps not yearly, it can every 5 years and so on. So comparing to conventional energy, I think cost of the generation is much lower. So it doesn't have to be handled by big companies, for example. Yeah.
Okay, thank you, Professor Hendro.
Yeah.
Thank you very much, Professor Hendro, for your question. And this is another question from Mr. Hawk Henry. Henring,
Hauck
please.
Henring, yes.
Okay, Hauck, please.
Okay,
These are just some remarks from a German, native German perspective. I think there is a quite high awareness of an necessary change to renewable energies in Germany. But I think there's also quite difference because energy costs are not a leading cost factor for not typical German family. I would say, I think we spend around 250 euros a month for fuels and all electric power and so on. And when you think, I think some average income for families around 4,000 to 5,000 euros. So it's not a big political issue if there's an increase in these energy prices. It's totally different for industry, for example, steel industry, or it's very significant if you have there some price changes. And this is only a small remark from my side.
Oh, okay.
Thanks.
Okay, thank you very much for your remark, Mr. Hauck Henring. Only 2 minutes left if there is any question. Okay, it's very interesting area. Actually, I have many questions, but I think we have many time in the future, Professor Hendro. We can collaborate after this event.
Sure.
Okay. And maybe one question last: how to acquire the data from the company, or maybe from to acquire the data, Professor?
Yes, from the we collaborate with companies, so that means
real time
like this,
or not?
Yes, the Stadtwerke has kind of recording of their energy generations. So we just choose some of the facilities, not all of their facilities. So it's almost real time right now, but they still work on to make it more real time, at least to provide to us. And then we use for the consumption side from these two companies, we install some metering systems there and install free software called Open EMS.
Open EMS.
Energy management system.
Open EMS. Okay.
So that's to collect the data and then to transfer it to the cloud.
Okay.
And I want to show you a bit what this is kind of intermediate
index
results.
Okay. The index, energy transition index in. Okay.
It's called Green Electricity Index that's developed by one of our partners, the company called Stromdal. So here, if you, for example, input your city or your zip code, then it will give you some kind of hourly predictions of how much energy, green energy, will be available in the city. So like here, green means a lot of much energy there. So that means you can, then the energy should be cheap there. So we haven't integrated the price yet, but then you can do some activities here. But if it's gray here, for example, I think it's because of the night, because of the dark, the availability is low. So that means only 33% here, 35% here, and so on. So it's like a forecast for the next 3 days.
Okay, very interesting. Okay, I think finally we know in the end of this session, Professor, because the limitation of the time. So thank you very much for your presentation. And on behalf of the committee, we would like to express our great gratitude for Professor Hendra as keynote speaker who delivering this material very good. I think that's all for this session. Thank you very much. And once again, thank you, Prof. Indro. Matur nuwun. Ya, kita jumpa lagi nanti di lain waktu. I think I will give back to Master of Ceremony, Miss Bianti. I think this time for you. I will resign. Okay. Thank you.
Okay. Thank you, Dr. Pringo, for your smooth and pleasant leading the session. And also thank you for Dr. Hendro for your interesting and very insightful presentation. Thank you.
Ladies and gentlemen, the next session shall be the plenary session. Kindly please join the plenary session by self-assigning to the plenary room, and the session shall be starting promptly at 2 p.m. for plenary 2 in room 2 and plenary 3 in room 3. Session in plenary 1 in main room shall be starting at 2:45 p.m. This is the list of our invited speakers of today's plenary sessions. You are welcome to join the plenary session by self-signing to the plenary room. Ladies and gentlemen, for all participants, you can click the link on the chat box to join the plenary session. You are welcome to join the plenary session by self-assigning to the plenary room. Please open the chat box and click the link.
Okay, once again to all participants who are interested to join the plenary session, you can click the link that are sent in the chat box to join the room. Thank you.
Assalamualaikum, Dr. Syed Helmi. How are you?
Assalamualaikum. Good. Alhamdulillah. Thank you.
Alhamdulillah.
How are you, Miftahul Anwar?
Alhamdulillah. I'm fine.
Alhamdulillah. So finally, we are at the time of the events. Inshallah, very fast. The time ran very fast. Alhamdulillah. So
Okay,
how
let
is
me.
okay, I'm gonna start.
Let me start. Is it okay?
We have another 5 minutes, right?
Yes.
Okay.
We have another five minutes.
Yeah.
But I will let. I'm going to introduce your CV first. Yes.
Yeah, sure, no problem.
And then we can start the presentation. Okay. Okay. Again, dear all participants, welcome to the disciplinary session, room 1 of the Icimece 2021. I would like to thank to all participants, for joining again this room 1 plenary session. Again, my name is Miftahul Anwar, and I will be your session chair. Here we have the last invited speaker, which is Prof. Madya Dr. Syed Ahmad Helmi bin Syed Hasan from University Technology Malaysia. Yes, we have around 20-minute presentation and 20-minute question and answer. Okay. Okay, I would like to now inform you the CV of Professor Syed Ahmad Helmi. He is now a faculty member of Faculty of Engineering, University Technology Malaysia. He received his Bachelor of Science in Mechanical Engineering from University of Alabama, Master of Engineering in Advanced Manufacturing, and PhD in Engineering Education from University of Technology Malaysia. Yeah, he is now currently a fellow at the Center of Engineering Education, head of University's Research Group in Engineering Education, RGEE, and the coordinator for Future Ready Educator, FREE, for School of Mechanical Engineering. His research focuses on industrial engineering and engineering education. His recent work, including academic change management, complex engineering problem, virtual reality and spatial visualization, manufacturing system and optimization, supply chain, and system dynamic modeling. He also received many awards, such as Teaching Excellence Awards, Excellent Service Award, Best Paper Award, and Gold Medal in Innovative Practices in Higher Education. He also published several books and more than 100 papers in journal and conference proceeding. Okay. Okay, to begin this session, I would like to invite Prof. Dr. Syed Ahmad Helmi to present his paper entitled Improved Design Solution for Motion Resistance Problem Using Theory of Inventive Problem Solving. Is it right?
Yes,
Prof?
yes, it is.
Okay. Okay, please, time's yours.
Okay, thank you very much for the nice introduction. I'm very honored to be here today. I think this is my fourth being with the ICI-MECE conference. I'm very pleased to be with you every year, mashallah. This is very interesting conference, and I hope you'll be very successful and be very consistent and very successful in the future as well. So my presentation is about one of my students' work on improving design solution for motion resistance using trees, right? Myself as a second writer, co-author, and Yong So-yi is my student. And together with Prof. Hisham, we come up with the the paper for this conference. Okay, actually the study is about vacuum cleaner, the bin assembly. As you can see here, this is the bin assembly. Okay, the problem with the bin, the bin assembly is used to store dust and also housing for filtration. Okay, and it will hold the this part, which is the dust tank bottom cover. So we call it as DTBC, right? The dust tank bottom cover, and then we have the seal, right? The seal that will seal both the dust tank and also the dust tank bottom cover. Okay, and we have the locking mechanism at this dust tank bottom cover to prevent the dust from move outside from the bin. Okay, the problem here is the bin emptying force always being tested out of specification, and this will cause a negative effect to the beam emptying force, and there are actually lack of idea generation on the product design improvement. I can say that it was almost saturated of come up with the ideas. So because of that, we apply the trees and aris concept. If you can see here from this data, okay, most of the bottom closing out of specification. Okay, the specification is the force should be between 10 to 30 Newton. For the beam closing should be around 30 to 60. And you can see here the beam opening is all within the spec, but the beam closing is not. Most of the data are out of specs. Okay. 70 from this data, 71.2% of the sample exceed the specification of the force, which is the force limit, which is 60 Newton. Hence, our beam closing force need to be improved. Okay, this is when we use the instrument mechanism. We can see here after around 3.4 millimeter, the distance from the datum of the bin, the Newton, the force is around 60 Newton, 61.58 Newton, which already exceeding the limit. Okay. So here is how the things work during the test using instrument. Okay, the movement, and you can see here this is the maximum load extension. Okay, which already exceed the force. Okay, this is when it is fully closed. So we have somehow to find a way of how to reduce the force. So how to improve the beam emptying force of bin assembly for the vacuum cleaner. That's our objective. And we going to evaluate the part design of the product which produce the negative effect, and to assess the product design improvement solution using trees and aris to meet the specification requirement. And these are the scope of the study here. We will study bin assembly of vacuum cleaner, and we will do some analysis in order to ensure the performance using the data that we have, and then apply trees and aris. The study is actually conducted in one of the manufacturing company in Malaysia. Okay, this is the framework for aris. We have the problem statement, and then from this problem statement come up with the contradiction formulation, and then we do the conflict analysis, and then do the elimination of the search. If we have the solution, then we implement it. If not, we do another iteration on finding out another contradiction formulation, and the thing goes on until we solve the problem. So this is the interaction analysis. Okay, all the parts here we have the dust tank, we have the bottom part, and the seal, hand, dust, and also ambient air as part of the system, and also force and motion And we see the interaction here. So the interaction, there's a interaction between dust tank and also dust, the DTBC. We can see a positive interaction, but sometimes we have the negative interaction, meaning there is no interaction between, for example here, the interaction between DTBC seal and hand, there is no interaction because actually hand doesn't touch the DTBC seal. So from here, we come out with the function model. This function model is very important before we come up with the contradiction matrix. Contradiction statement. So the hand, for example, here hand will hold the dust. At the same time, it will hold the DTBC, right? And the DTBC will push the DTBC seal sufficiently, will block the air ambient. And then the dust tank will block the ambient as well and will generate the force. Okay, the same goes with the DTBC. It will generate force, right? And so from here, okay, we do the cause and effect analysis. So from here, we do the trimming. Okay, from this trimming, we found out that the excessive friction of DTBC, okay, which is actually the useful to ensure the useful of bins, the seal bins. So this is where we will concentrate on. Okay, from there we come up with this contradiction statement. We have two contradiction statement here. The first one, if the friction force of the dust tank and DTBC is higher, then the air leakage of the bin assembly is lower, but the force to push the DTBC is higher. That is the first contradiction statement. The second one is, if the friction force of dust tank and the DTBC is lower, then force to push the DTBC is lower. That is what we want. But then air leakage of bin assembly is higher. So from here, we can see that the useful contradiction here, one is prevent the air leakage, and the other one, the harmful contradiction here is force to push the DTBC is higher. So from here, we decide to have this contradiction number one, which is the will enhance the friction force of the dust tank and also the DTBC when bin closing we choose the contradiction number one. We will make the force to the leakage of the bin assembly is lower. And then we have to analyze why and how the force to push the TBC is higher. So how to solve this problem? So based on these two contradiction statement, okay, here we have number one is the first one is the ease of operation, and the second one is the force. From ease of operation, which is parameter number 33, and also parameter number 10 for the force intensity. So from here, from this contradiction statement, based on the metric contradiction matrix, principles number 13, 28, and 35 can be applied to actually to improve the ease operation and also to reduce the force. So in order to reduce the force and to improve the operation, we will apply principle number 13, 28, and 35. These principles are principles of mechanisms substitution, which is number 28. The other one is the other way around, the principles number 13, and also principles number 35. Okay, the parameter change. These are the description of these principles. From this description, okay, the one that can be applied for our problem is the first one, which is number 28, principle 28. it changed the static of movable field from unstructured field to those have structure. And then for 13, we have 3 possible solutions. One is to invert the action used to solve the problem. And the other one is to make a movable part to make the movable part fixed and the fixed part movable. And the third one is to turn the object or process upside down. So these are the solution based on this principle. And the solution based on parameter, there are several solutions, but solution which are possible to our problem is change the degree of flexibility. From these 3 parameters and these 3 description, all right, we came up with several potential solutions. Over here, you can see around 16 potential solution. Out of this 16, we analyze which are some are not possible to be applied. So from here, we select 10. From this 10 of the possible solution, we use 6 proposal that to be applied to solve the problems. Okay, these are the 6 possible proposal. Number 1 is we apply the dust tank without DTBC. All right. So here the principle is number 13, which is the other way around. So the method to use is upside down the function of being removable and fix the movable DCBC. Over here, the pro is the air leakage will improve. There's no friction, but the con is very difficult to remove the dust. So you have to remove the dust from the top instead of from the bottom. Okay, the other possible solution, proposal number 2, is we still use the other way around. Over here, the method is inverse the interaction function of dust tank and also the DTBC. The pro here is it will reduce the friction, and also the DTBC can easily fall. But the cons here is less strength of the DTBC chips. Okay, and then proposal number 3 is we apply principle number 13 and 28, which is the other way around, and also mechanism substitution. So the method that we apply here is point contacts that replace the surface contact and also change from flat surface to rolling surface. Over here, the pro is it will reduce the friction and also the surface contact area, but the cons here is it reduce strength of the DTBC clips as well. Okay, and then the proposal number 4, apply principle 13 and 35. The method to be used here is we increase the gap between dust tank and also DTBC, and also at the same time we decrease the width of the DBT chip. So from here we can actually reduce the friction and also interference, but then less strength of DTBC chip as well. Then we have proposal 5. Proposal 5 is actually we apply principle 35, which is the parameter change. The parameter that we change here is the gradient. So we increase the gradient of DTBC catch on the dust tank from 40 degree to 60 degree, and also the distance the distance instead of 3 millimeters, we make it 2 millimeters. With this, we can actually reduce the friction and also increase the strength of DTBC, but there is no cons here. And then the last one is proposal number 6, which is applying mechanism substitution. Over here, we add rubber strips on the edge of the bottom of the dust tank. And the pros here, we reduce the air leakage, but then we will increase the friction and also increase the interference, with actually will increase the force as well. So we use the plug matrix on all this proposal. So out of this proposal, we can see here the weight for proposal 5 is the highest, which is meaning the best. But we actually look at 3 possible solution here, which is proposal 1 and also proposal 4 and 5. Using these 3 proposals, we run the simulation, use the solid modeling simulation. And from here, the best in terms of the shear or the strength, which is number proposal 5, which is 613. So this is the best. Actually, it will reduce to almost 73.5% of the stress. So that is our solution. This is the best solution of how to solve the problem that we have. Okay, so the objective is achieved. The force actually reduced 73.5% from the original design. Harmful effect parts design are determined using ARIS. From here, we propose 6 proposals. And then from this pre-proposal, we find the best, which is proposal number 5. So I think that's about it. Yeah. We, as a recommendation, the fixing structure are quite difficult during the production, during the product development process using ARIS. So ARIS flowchart is very useful for the schematic of project design and also structure analysis, and it is used as an analytical tool that that is suitable to be used for fresh test user. It is very step-by-step process, and it also can be adapted to other system in the new we have new parameters. Okay, that's all from our presentation about the project or from the paper that we propose here in this conference. Thank you.
Thank you very much, Prof. Syed Helmi, for the nice presentation. For participants who want to ask the question after this presentation, please raise your hand or type the question to the chat box. Okay. Any other question or comments about this presentation?
If I can't answer your question, with me, I have my students. She can answer the question as well.
Oh, okay.
Yeah, she's with me now.
Nice. Yeah. Any other question about these topics? Prof. Syed Helmi, I have one question.
Yes.
Firstly, you said that your data about the force to open and close. Could you explain again what does it mean? I mean, it's not
okay. Over here. Okay, let me show the. Okay, when we want to take the dust out from this bin, right? You have to open it. You have to open, all right? You have to squeeze a bit. I mean, you have to twist a bit. Then you open this. When you open, okay, this is the bin, right? You want to take the dust out. You use this at the bottom here. Okay, you will do there's a clicking mechanism here. It will open this bottom. Once you open it, you have to close it back. When you close it back, you will apply a certain force. Okay, you will apply a certain force to close back the bin assembly. During this closing, the force is a bit quite high, which is above the specification. If the force is high, then after a certain period of time, it will actually destroy this bin assembly. So the force is always out of spec. So that's why we need to study on this closing mechanism.
Oh, so this you use this kind of vacuum cleaner, yes, with the bin on the top of the vacuum.
This one, yes, this is the vacuum cleaner. This is the where the dust being collected. So once it's collected, then you need to to open it to actually throw away the dust.
I see.
Okay, you open the bottom part here to throw out the dust. So this is where it's always out of spec when you want to close it back. when you want to close it back, it actually you need to apply more force than what is required. It have to be less than 60 Newton, but always it is more than 60 Newton.
So this number of force, I mean, your student also take the data, or
this is the data
take from another?
This is the data taken by the students.
Oh, I see.
You can see here, most of the data here is out of spec, more than 60 Newton. The closing mechanism must be between 30 to 60 Newton. We don't have problem with opening, but the problem is with the closing.
With closing. Durability. Okay. Any other question from the participants here? You can raise your hand or directly open the mic. Okay. Maybe Dr. Pringo, you have any question? Or any other person? Or maybe Dr. Hisam, you have another comment? This is your paper, actually.
Yeah. I hope he doesn't have any question.
Maybe not the question, but
yeah,
comments or
comment.
something.
Yeah. Hopefully, this collaboration can be continued in the future. Yeah. Thank you.
Yeah, inshallah. Inshallah.
Okay.
Yeah.
Okay. Could Prof. Helmi, could you go to the simulation result?
Oh, the simulation. Okay.
Yeah. Simulation result.
Mm-hmm.
You only present one result, yes?
Yes, only one result. That's right.
What about the other?
Actually, the other also, we do the simulation for others as well. That is the optimum one.
Oh,
that is the best result. Yeah, the solution 5. Yeah, which is the most less in terms of the stress. The result is based on stress, but actually is from the force.
The number of stress is around 600 million, yes? Or
yes, 614.
614.
Yeah.
Okay. Okay. Any other question from the participants here? Okay. Oh, Dr. Pringo, you have any question, please?
Okay, Assalamualaikum, Prof.
Waalaikumsalam.
Helmi. Alhamdulillah. As I know, I know, TRIS technique is kind of a trade-off or contradiction technically or improving design for problem solving for product development. I want to know about ARIS. Arise. What is Arise?
Aris is one of the tool that we use to make it more simpler. Yeah, to make it to skip several steps in TRIS.
Yes, because as I know, TRIS is many steps. There are many steps, maybe
many tools.
Many tools.
Yeah, and one of the tools is Aris.
Oh, one of the tools is Aris.
Yeah, and Aris actually will skip the process of analyzing it to make it faster.
Okay. And what is the most factor, the most important factor to have maybe significant factor have a trade-off if one factor developed, another is decreased significantly?
Okay, the most important factor is here, the contribution.
Oh, the contribution.
Yeah, this is the most important factor. if we come up with, if the contradiction statement is not correct, not right, right? Then the solution will be different, because from this contradiction, then only we come up with, we see what are the principles to be used. Okay, so this is the contradiction here is ease of operation and also force. Will improve the operation and also it was worsening the force, which actually comes from this contradiction statement.
Okay.
So this is the most important aspect in TRIS.
So and then you propose a 5 proposal and then conduct it in the simulation, and you got the fit proposal is the best for the design.
Using
simulation.
2 ways. One is by using Park matrix.
Okay. Metric also.
Use Park
matrix
matrix.
also.
From this Park matrix, then we select the best 3. Then the best 3 we use simulation.
And about the Park matrix is also using subjective or objective.
Because we have the rating here.
Rating.
This is quite subjective.
Quite subjective.
But subjective.
But using expert maybe can with the expert with the expert experience we can eliminate the subjective of the system.
We can eliminate the error.
Okay.
Probably we can apply
very
ASP, very more promising result. Instead of just come up with from the experts or
Yes, that is the important of the expert to give the subjective to give a rating, so
the
we can eliminate the we can eliminate the error. I think interesting. We can conduct this kind of method with another project or another. I think that's all, Mr. Anwar.
Thank you, Dr. Pringo.
Okay.
Appreciate your question.
Okay, thank you.
Thank you, Dr. Pringo, for the question. And I ask again for the participant, do you have any question or comments to the presenter? Okay. If not, maybe we can end this session. Thank you very much again.
Thank you. We appreciate.
Said Helmi.
Thank you, Dr. Anwar.
Maybe next year we'll meet again. Okay.
Inshallah.
Okay. We hope that we can get the benefit from this presentation. Again, I must thank all participants for joining this parallel session, and we hope we can get many experience and benefit from the presentation. Thank you very much, and I would like to close this session. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih.
Ya. Terima kasih Prof. Said ya. Prof. Said ya.
Sama.
Ini beliau nih baru ada acara nih, nyempatin di acara kita. Ada workshop beliau.
Ada workshop. Terima kasih ya Pak Isyam.
Terima kasih Prof. Ya.
Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh.
Excellencies, distinguished guests, participants, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. Welcome once again to the 7th International Conference on Industrial, Mechanical, Electrical, and Chemical Engineering 2021. It is very nice to see all of you once again, and we hope you have been enjoying yourself at the conference so far.
Excellencies, distinguished guests, participants, ladies and gentlemen, we have had productive and inspiring time together, and this event is about to come to the very end. I hope you found the presentation on this conference are very informative and helpful. Now, before we conclude our today's activity, we will announce the award ceremony for the best paper and best presenter of each study program. And to enliven this session, you are pleased to join me to open your camera. Thank you. Do we have the award announcement slide ready? Okay, please wait for a moment. Okay, we will start the award announcement. The Best Paper and Best Presenter of Industrial Engineering Award. The Best Paper Award of 7th International Conference on Industrial, Mechanical, Electrical, and Chemical Engineering 2021 goes to Wahid Ahmad Jauhari, Inyoman Pujawan, and Moh Sueb, with the paper title, A Cooperative Manufacturer Retailer Inventory Model with Carbon Tax Regulation, Imperfect Production, and Rework. Congratulations to the winner. The best presenter of the 7th International Conference on Industrial, Mechanical, Electrical, and Chemical Engineering 2021 goes to Congratulations to Fauzia Amelia Ananda with the paper title Consumer Preferences of Electric Motorcycles in Indonesia, a choice-based conjoint analysis. Congratulations to the winner.
And now, the Best Paper and Best Presenter of Mechanical Engineering Award. The Best Paper Award of 7th International Conference on Industrial, Mechanical, Electrical, and Chemical Engineering 2021 goes to Abian Muafak, Syamsul Hadi, and Zainal Arifin with the paper title The Effect of Electrospinning Precursor Flow Rate on Zinc Oxide Nanofiber Manufacture Using Rotating Drum Collector on Double Layer Dye Sensitized Solar Cell Performance. Congratulations to the winner. And then, the Best Presenter Award of 7th International Conference on Industrial, Mechanical, Electrical, and Chemical Engineering 2021 goes to Bayu Sutanto, Budi Kristiawan, Indriyaningsih, Agung Triwijayanta, and Takahiko Miyazaki with the paper title Numerical Approach of Titanium Dioxide and CNT Nanofluids Flowing in Circular, Rectangular, and Triangular Tubes. Congratulations to the winner.
The Best Paper and Best Presenter of Electrical Engineering Award. The Best Paper Award of 7th International Conference on Industrial, Mechanical, Electrical, and Chemical Engineering 2021 goes to Congratulations Eni Wardihani, Shiriko Asetiawan, and Muhammad Mukhlisin with the paper title Low Density Parity Check Codes LDPC 5G New Radio Performance Using Modified Min-Sum Decoding Algorithm. Congratulations to the winner. And the best presenter of 7th International Conference on Industrial, Mechanical, Electrical, and Chemical Engineering 2021 goes to Congratulations Ivan Robis Septian, Miftahul Anwar, Maulana Yusuf, Rizky Ram, Rizky Ramakusuma, Pandi Surya Adinata, and Teguh Enda Saraswati with the paper title Design and Analysis of Monitoring System of Ozone Producing Plasma Corona Discharge as a Disinfectant. Congratulations to the winner.
The Best Paper and Best Presenter of Chemical Engineering Award. The Best Paper Award of 7th International Conference on Industrial, Mechanical, Electrical, and Chemical Engineering 2021 goes to Congratulations, Mr. Margono, Mr. Mujtahid Kaivisena, Mr. Aswandi Asmadi, with the paper title Preliminary Experiment of Saccharomyces cerevisiae Immobilization Using Method of In Situ Flocculation. Congratulations to the winner. The Best Presenter Award of 7th International Conference on Industrial, Mechanical, Electrical, and Chemical Engineering 2021 goes to Congratulations, Febrianto Adinugroho, Putu Teta Prihartini Arianti, Astrid Aprianti Dania, and Fitria Febriana Sari with the paper title The Influence of Mixing on Electroregulation Performance During Soy Sauce Wastewater Treatment. Congratulations to the winner.
The Best Paper and Best Presenter of Special Symposium Icimece 2021 Award. The Best Paper of the 7th International Conference on Industrial, Mechanical, Electrical, and Chemical Engineering 2021 goes to Congratulations, Mr. Quang Thanh Du from Department of Naval Architecture and Ocean Engineering, Nha Trang University, Vietnam, with a paper titled Residual Ultimate Strength from Formulation of Submarine Pressure Hull Subjected to Collisions of Attendant Vessels or Floating Objects. Congratulations, Mr. Quang.
The Best Presenter Special Symposium Award of Severn International Conference on Industrial, Mechanical, Electrical, and Chemical Engineering 2021 goes to Congratulations, Mr. Moritz Brown, with the paper title Recent Progress on Geometrical and Concentration Characterization of Welded Joints. Congratulations, Mr. Moritz Brown. Okay, ladies and gentlemen, congratulations to all the winners. To those who could not make it today, I believe there is always a room for improvement. Do your best in the future. Ladies and gentlemen, we have now come to the end of the closing ceremony of the Severn International Conference on Industrial, Mechanical, Electrical, and Chemical Engineering 2021. We would like to extend our gratitude to all the keynote and invited speakers for sharing a very insightful speech and knowledge. Not forgotten, to the participants of this conference, we would like to convey our utmost gratitude for your participants and support.
Okay. Now, I would leave you with a quote by Stewart Brand, an author and innovative thinker who once said, "We can see the past, but not influence it. We can influence the future, but not see it." Let us all be guided by all the things we have learned and heard throughout the conference and be able to see and influence our future. Thank you, and thank you very much. And before we part, please accept this verse from us. Kalau ada jarum yang patah, jangan simpan di dalam peti. Kalau ada silap dan salah, harap sudi maafkan kami. Which roughly means, please forgive us for our shortcomings. Till we meet again, perhaps in the next conference, may you have a pleasant evening. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh.
Congratulations to Dr. Mustahid as organizing chair of Icimece.
Thank you very much for a good conference. Bye-bye.
Hey, thanks, Prof. Anita Peterson. See you next time.
Yeah, hope so. Bye-bye.
Bye.
Thank you very much for the kind invitation. I enjoyed the conference a lot. Thank you. Bye-bye.
Thank you, Mr.
Yes, thank you very much.
Thank you, Mr. Moritz.
Thank you, Mr. Quang.
Congratulations.
Thank you.
Congratulations, Mr. Quang Thanh Du.
Oh, thank you very much. Yeah, I hope see all of you in next conference. Okay, now, bye-bye.
Bye-bye. Thank you once
Bye-bye.
again.
Thank you, Mr.
Assalamualaikum. Okay.
Oh, yeah. Yeah.
Thank you.
Hello.
Congratulations also to the two master ceremony that's already lead the conference from the morning until finish, the afternoon. Good luck. Maybe you get experiences for this event. Thank you very much.
Thank
you
you.
very much, Mr.
Assalamualaikum. Selamat ya. Pekerjaan dia toh. Oh, lah yang penting kan kualitasnya toh. Yang penting kan kualitasnya, sing nulis anu level dokter dokter apa sih nih? Dokter wis dokter aja tau ning meh profesor kok. Aku dunia ini tuh hadiah lu ya syukuran ngono apa piye.